Tonight we're going to have a sauna party. You don't have to sign up for it. You're welcome. Maybe preferably you would bring your swimsuit, even though Finns like it nude, but you don't have to. And then we provide your towels and some drinks and food at the venue.
And another event for tomorrow evening is our local Helsinki JS chapter. They're running a special event where they're actually having a couple speakers from Future Frontend participating in the local event. So if you want to get a little bit of more local Finland flavor, meet other people who may not be at the conference, I strongly encourage people to go to the Helsinki JS event, catch a couple other speakers there, and just see a little bit more of Finland, of Helsinki, and meet a little bit more of the community. I know when I speak in other conferences, I always try and go to a local event like this as well. So I strongly encourage other people to check this out because I think it's going to be a really, really worthwhile time.
Yes, we are following the Berlin Code of Conduct. We haven't had any problems before, but if this year is different, let us know. You can find our crew. You can recognize them from the T-shirt that says Future Frontend, and there's a staff on behind. Sorry? Oh, yeah, or follow the Iron Maiden. And we handle any problems behind the sauna. So. Yes, and if somebody's wearing a red lanyard, please respect their wish not to be photographed.
And yes, last plug is if you're posting anything about the event on social medias, be sure to use the hashtag FutureFrontend so that we can actually share and collect all of the memories, all the ideas, and all of the events that happen over the next couple of days. For the questions, we're going to be using this clapper.co. If you haven't heard of it, join the club. But if you go to clapper.co, you can sign in with the event code, this FF25, and that will give you access to our questions panels. So during any of the presentations during the event, you'll just sign into clapper.co, post your questions there, and you can upvote and support other questions as well, and probably interact with other people posting as well on there. And then that is where we're going to pull questions from to ask at the end of presentations to have further conversations. So to ask questions to the presenters during their presentations, go to clapper.co, log in with the code FF25, and that's going to be your way to do that. So that's how we're going to be handling questions. We will remind you all periodically throughout the day and throughout the event. But for those who want to get an early start, this is where you shall go. Lastly, we do have a Future Frontend Slack channel, so be sure to join there. Again, you can interact with other attendees, speakers, and just be aware of the latest goings-ons in the events. And I think that's all the housekeeping that we have. So I would love to introduce our first set of speakers today, who are covering a very important topic around the performance and the ability to debug in DevTools. So I'm very interested in this to see how we can utilize the DevTooling better, because I know I've been using it the same way for the past few years, and there's going to be a lot of things that I can learn that are new. So give a really warm welcome to our first speakers of the event, Eva Gasparovich and Barry Pollard.
Can we get the screen over to? Hello. Oh, there, working. We're going to try another short video since the last one worked so well. Audio will work. Workish. Listen very carefully. Say again?
Can you hear it, or it's not hearable? Kinda.
HDMI. Oh. Oh, there we go. That's better. Panic.
Don't break it, Barry.
Oh my goodness. This is going superbly well.
That's okay. Nothing secret there. We'll tell you anyways.
Hold on, 2 seconds. Trust me, we're going to get better at this. Where's my mouse gone?
Go.
All right, shall we get started?
Yeah, hello! Hello to the conference. Finally, we can start. So, I'm Eva,
And I'm Barry.
and we work at the Chrome Web DevRel team. And today we're going to tell you all about the fantastic features you've just seen in a slightly silent video.
Okay, hands up here who use Chrome DevTools as their main DevTools. Like you can include Edge and all the other Chromium-based browsers. Firefox? A few Firefox. Safari? Okay, looks like Chrome's winning again. We'll take that as a winner.
Well, actually, we're very happy that DevTools, Chrome DevTools, are really used and loved by so many developers worldwide. And the DevTools team is really hard at work of improving it even further. So we listened to your feedback. We implemented a lot of features that me and Barry are gonna, is it better now? That me and Barry are gonna present to you today. We're gonna talk about AI assistance that now is available in multiple panels. And actually, since recently, it allows you not only to debug your problems in the browser, but also fix it directly in your code without leaving DevTools. We'll talk about the live metrics view. That is a great introduction to the performance debugging. And we will talk about performance trace improvements that we introduced to the DevTools. Finally, we'll share some tips about annotating and extending DevTools for better collaboration in the team.
Okay, so talking is fun and interesting, and trust me, I will talk all day if you let me. But I think it'll be much more interesting if you actually see some of this in action. So time permitting, we're running a little behind time at the minute, so we'll see. We'll spend the first third of this giving a bit of a presentation. Then we're going to ask you for some audience interaction. So we want you to suggest some sites that we've never seen before. We're going to see some of the things that we've demoed to you here and actually try it on the site for the first time. So we'll see how well this works. And maybe we'll do some performance analysis. Maybe we'll use AI to fix some sort of things or stuff like that. Really to actually just drill home what we're seeing here and actually see what we're doing now. So over the course of the next 35, 45 minutes while we're talking, have a think about that. Maybe it's your own site. Maybe it's a competitor site that you really want to embarrass on stage. Maybe it's a site that you absolutely hate using. We're going to ask for one or two suggestions out there at the end of this presentation. And then after that will be some time for Q&A, and you can ask us what we didn't explain very well, or any other questions?
So that's the plan. A quick mic check. Can you hear me right now well? Or I need to speak like this? Like this? Okay, I'll speak like this. Oh, no, we're here. Okay, so we will start with the feature that we recently built into DevTools to help you when things get hard when debugging websites. So the AI assistance coding is really getting popular among developers. A lot of us use it right now in our everyday workflow, either in our ADEs or in the different chat apps. This requires a lot of context switching between browser and your IDE. This is why we introduced the AI assistance panel directly into DevTools, so that you can debug and use help and power of LLMs and Gemini directly in the browser without so much of context switching. It allows you also to quickly test what the LLM is proposing and to see if it will work in actual browser in action without context switching. So let's see how this works in the Elements panel. In the Elements panel, when you select an element, you get a little AI icon next to it. And when you click that tiny, tiny icon, you can directly open AI. It will directly open the AI assistance panel for you and will allow you to interact with Gemini. You can query Gemini about the element's layout and styles. And with simple prompts like, can you center image on this page, or why is my text overflowing its container, you can not only get actionable advice as to what is causing a particular styling issue, but you can actually fix the code directly in the browser. So if you are more visually inclined, now this is also an option. Like, typing is sometimes a bit troublesome. So using this little camera icon in the prompt area, you can take advantage of the multimodality of the model. It means that you can very easily grab a snapshot to tell the browser, to tell DevTools which part of the page it should fix for you. Let's see this in action. This is an example page. You can immediately see that one of the thumbnails is standing out. There is a problem on the page, right? It doesn't have the right aspect ratio. So we would like to trim it to resemble the other images. Now, if I click the icon and click the camera icon, I can easily grab a snapshot. This snapshot will be passed on to the LLM, and I can ask it to fix my problem. It gives me some explanation on how to fix this issue. And I can immediately test it out in the browser. Now, as a last step of the what LLM gives me back is actually a code snippet. And if I click this continue button, it will actually apply it directly on the page, and we can see that the thumbnail got fixed. Now, the changes that the LLM applied to the page can be seen in the changes panel. It just displays a difference between the previous state and the current state using the normal heuristics of the difference panel, right? In green, it shows stuff that it added to the code, and in red, the lines that were removed. But this change is kind of temporary, right? It's very similar to as if you were editing styles manually in the styles, in the elements panel. This means that if we reload the page, the change will be gone, right? And this is kind of sad. So we decided to change it. Since a few weeks, you can actually preserve the changes you make through LLM in the DevTools with just one click. This is how this works. This project is running on my local server, which means I have the code base for that page available on my local computer. If I connect my folder, where is my code base, to DevTools, I get this nifty apply to workspace button. And then by clicking it, these changes we made so far only in the browser will get preserved to the actual file system on our computer. Of course, first you need to set up that folder connected to the DevTools. It's called Workspace feature. You can find Workspace tab in the Sources panel. So how to set it up? First, you need to grant permissions because, of course, nobody wants DevTools or Gemini edit directly files that you didn't agree to be accessed on the file. So you need to grant the right permissions for the folder. And then you get that connection option in the sources panel, but also you get the apply to workspace feature in the LLM. In order to connect folder, you can either do it manually in the sources panel, or actually we now have a mechanism that is called automatic workspace discovery. How does automatic discovery work? If your local server is exposing a JSON file on a particular URL, it's called well-known app-specific Chrome DevTools JSON. This file is following a particular protocol called DevTools JSON. It's a very simple file. It just really gives a path to your local folder and some ID that the tools can recognize, okay, this is the folder for this particular workspace. If you expose such file on this URL, the DevTools will automatically pick it up and offer you the connect option in the workspace. You can either expose this URL yourself, or you can actually use one of the integrations that we're having. Angular right now supports it natively, so if you start a new project with Angular, it will expose this JSON file on this URL for you automatically. And if you're working with Vite-based projects, we offer a plugin that you can use in your project in order to get that URL exposed for you. You can read more about the automatic workspaces in this article on developer.chrome.com. Okay, so I would try to run you through an end-to-end AI-assisted coding example in DevTools. Let's hope it all works. So this is the chrome.dev page. This is a little playground we built for you to try out different Chrome features. On chrome.dev/devtools subpage, you can see different riddles that you can solve with the help of DevTools. Feel free to check it out in your free time or in your work time, depending. So on the overflow subpage, we get a few riddles related to overflow. And here you can see in the water, there is an image of a diver. But this diver kind of fell off the screen, right? It's not fully visible. Obviously, it's a visual bug we're having. So what can we do? If we click on the SKI icon, we can simply ask, like, why is this element not visible on the screen? And the Gemini will give us some explanation why it thinks it might be the reason. So we can now take this advice and fiddle in the code, or we can take it further and actually ask Gemini to fix it on our behalf. Gemini comes up with a snippet of the code, and if we click continue, that yes, we want to apply the snippet, it will apply this patch to our code and move the diver in the right place. Now, because I'm running this project on my local host and I expose the DevTools JSON file, I get the connect option in my workspace. Because I have this connect option, the folder is also picked up by the Gemini in the conversation flow. As you can see, it displays it in the unsaved changes part of the conversation. Now, what I can do, I can click the apply to workspace button. I grant the right permissions in that step, and the change gets applied to my code base. The magical part here is that this project is actually using compiled CSS. So the source file is in SCSS, and the whole project uses Next.js framework. So here we also use AI agent to figure out how to translate the changes that were done in the CSS before to the source files on our local code base. It displays the proposed changes, and then we can either accept it or refuse it if it made an error. And if we accept it, we get notification that the changes were saved to disk. We can see those changes in our IDE, of course, and in the local files. But because we connected it to the DevTools, we also see it in the sources panel. In the sources panel, you get the Workspace tab. You can go there and see all the changes that the Gemini applied to your code base. Here you can see that actually SCSS file was changed, not CSS directly. And also you get a notification that some of the changes in that file were AI generated. Sometimes when there's a lot of changes and we mix manual changes with AI changes, we like to know where those changes come from. You can read a lot more about applying AI-assisted AI-assisted coding in styles in this article.
To performance, but the bulk of this talk is going to be about the improvements we've done to the performance panel. Now, I don't know how many of you are used to doing performance problems or have tried to look in there and been a bit scared, but I'm going to take you through the whole front to back of looking at performance issues, understanding them, maybe using a little bit of AI to help if you can't explain them yourself. So hopefully, if you've never done any performance tracing before, you'll be less intimidated by it and you'll be more willing to go in there and have a look, because we've done an awful lot in this panel. So this is a performance trace, and as Ava said to me in the past, this is quite intimidating whenever you first go in there.
I'm intimidated.
Yeah, I mean, how can you not be? There's an awful lot of information there. I have no idea what it means. It's a big flame chart. Once you're an expert in this, you're like, oh yeah, I know exactly what it is. But the first time people go in there, they maybe have a look at it, then they kind of back away and say, yeah, I'm just going to leave it to it. Maybe I'll go and do that lighthouse. It seems a little bit easier for me. Because you don't know where to start with this sort of thing. And that's something that we've been trying to work on for the last 2 or 3 years. So we kicked off a project and said, we're just going to have to see if we can make this better. Make it less intimidating, make it easier to follow, make it more friendly for people that are new to it, but at the same time not lose the power for those that are used to it. So, like whenever you first kicked it off, this is what you used to see in the performance panel, a big blank empty screen. Doesn't give you any information and just says, do one of those complicated traces and we'll see if we can get into it. Now, I don't know if you've been into it recently, but if you look into it recently, this is what you see. So you immediately see, for the page you've loaded, some performance metrics. It's centered around the 3 core web vitals. I don't know if you heard those, but those are 3 metrics that the Chrome team launched 5 years ago now, I want to say, to measure key aspects of your performance. So it's LCP, which measures how long the largest content takes to load. CLS, which is all those annoying shifts. You know, you start reading something and ad pops in and you lose your place and you're like, what's going on? And the most recent one, IMP, which is interaction to next paint. So from an interaction, how long does it take until the browser responds to that? Maybe not completely, maybe it's got to do some work, but at least it should give you some visual feedback that something's happened, your click's been registered, we're working on it. So as soon as you open a web page, you see those numbers. So without doing anything, you can see this website looks green. We'll come back to that in a second. And as you click around and move around this, those numbers are continually updating. So you can see the IMP numbers are moving, your CLS numbers might be moving. As you move to new pages, they're continually updating. So it really is a live metric screen. You can actually see live what's happening. That can be incredibly useful whenever you're not sure where the performance issue is. Is it this hamburger menu? Is it this button? Is it that? So you can sit there, play around, and actually see where the performance problem is, and then say, right, now is where I want to dig in and do a complete trace. You also get Oh, sorry. Yeah, one of the big problems is that we have typically nice developer laptops, and they're not always the laptops that our users are using. And we can't normally just ship out the beefy MacBook Pro to every one of our users, much as we'd like to do. So you're going to have to deal with the fact that your users are using less powerful laptops. So how do you bring?
Barry, like, not everybody has such a good laptop as you do.
We'll see in a minute. So we need to bridge that gap between what you're seeing here and you're saying, hey, it's all green, there's no performance issues here, and what your users are actually seeing. So traditionally, what DevTools has been is what we call lab-based metrics. It's running something while your laptop is effectively the lab. It's not representative of what real life is, and all the wild and varied different devices people have. So what we've done is we've now brought in some of the field metrics. So a few years ago, Chrome launched the Chrome User Experience Report, or CRUX, and that's what feeds the Core Web Vitals program that we measured. So when you first install Chrome, it says, are you happy to feedback anonymous data back to Chrome? And whenever you connect that up to DevTools, you can actually see the real user experiences for this website. So first of all, you have to click the button, you have to accept it. So it's saying, we will send this URL to Google to get the data, obviously, because we need to get the data. And you can immediately now see on the left our local lab-based metrics, and on the right what our users are experiencing. And you can see here already, even though I've got a really fast load time of LCP of 0.52 seconds, most of our users don't get that. Most of our users get 2.57 seconds. So immediately we can say, right, this is where we should concentrate on and look through. The other problem is that was desktop. When I switched to mobile, we see we've also got an IMP problem. So again, that was totally masked before. We didn't know exactly where to look. Now we know we've got two problems here that we really want to look at. You can also then set up your DevTools and your performance trace appropriately. So if we zoom in a little bit closer here, you can see most of the people on this website are mobile. That's not unusual. In fact, to be honest, this is a bit more desktop oriented than most websites. Most websites are up to 3/4 now on mobile. We can also see that 75% of our users are using similar to slow 4G throttling. So let's set that. You can see that's the recommended option, again, based on your real users. For CPU throttling, again, we have nice beefy laptops, and you're like, what should I use? Should I use 4x slowdown, 6x, 20x? Who knows? You just took a guess and tried it. Well, one thing we've added, now we don't have the real user data for this, but one thing we do have is we've got this calibration option. So the first time you run it, these will all be grayed out, but there's a calibrate option. You click on that, it will run some tests on your CPU, and it will figure out exactly what slowdown your desktop needs to simulate roughly a low-tier device or a mid-tier device. That means you are working on a beefy MacBook M4 latest thing. You might only get you might get 10x slowdown. If you're like me with my poor little M1 MacBook showing its age, it's recommending a 3.1x slowdown. So you working beside your colleague should get similar sort of data by looking at this. So yeah, we can apply those, and then we can also flip over to see what we're looking at. Oh yeah, we can also see the origin level data. So this is the data for all the site. So here we can see we've got CLS problems. So some of the other pages on the site might have a lot of that shifty content whenever ads slot in and that sort of thing. And that's particularly useful if you don't have URL level data, if we don't have enough information there to give that. Okay, there's lots more information as well. Whenever you look at that, if you hover over that, you get these LCP breakdowns, so these subparts where you can see how much time is being spent in it. It's quite often to see that you've got a super fast connection. Your time to first byte is super quick because you're probably sitting 3 feet from the data center. It's a warm cache. You've been reloading several times, whereas your users might be coming from the new overnight. All your caches have been empty. Your edge cache has been overloaded. They're looking at a page that hasn't been cached for a while or something like that. So it's good there, again, to just calibrate yourself with what your users are seeing. Similarly, INP subparts, we've got this interaction track. As you're clicking around, you see other bits of information in there. You can click on that for more information. You get the breakdown of how much time it's spending in each of those things. Okay,
so this live metrics view really gives you a good starting point to see where you stand with your page. But what if you want to dig deeper into all the issues and actually solve them, not only see the problems, but see the solutions? What do we do, Barry?
Okay, so that's where you drive into the traditional performance trace. So a performance trace, what it is for those that don't know, is it basically runs the website, either a page load or a bit of interactions, and it's collecting a lot of information, like way too much information to do it, and then it tries to present that in a visual manner. Traditionally, that's been in this sort of flame chart, which represents all the JavaScript executing on the main thread, and boxes show longer boxes, meaning they've been executing for longer. Those trees, or whenever it's going into subfunctions and that sort of thing. But again, as I say, a bit icky to look at, bits, where do I start? To record a trace, there's two ways, so you've no excuses not to do this. In the bottom right, so after you set up your field, you calibrate your DevTools, you can then hit record. Also in the top left, for those more old school of us, it's quicker for doing a second trace and a third trace and so on. You have two options. You can hit record, which just leaves the page as is, hits record, you click around, you do whatever you need to do to try and replicate the performance issue, and then you hit stop. The second option is record and reload. That's basically for investigating page load issues. So what it'll do is it'll start recording, it will reload the page, and once the page is finished loading, it will automatically stop recording, and it will say, this is what your page looks like loading, because a lot of performance issues tend to be in page load. So if we click on that reload and record, you see this does take a few seconds. So it's sitting there, it's gathering so much information that you're not able to do anything. So this is why using the live metric screen first, try and identify what your performance problem is, and only then going into the trace is a good way of going through it. When you load it, you get a slightly different view than you did in the past. And again, there's an awful lot of data here, but don't worry, we're going to take you through it. So for those that aren't familiar with it, you get, have I missed one? Oh, no, I don't. You get this mini map at the top, which shows all the screenshots of what happened during that trace. In this case, a page load trace. So you can see bits coming in, the headline, then the image, and so on, and that sort of thing. You get all the JavaScript executing that you can just see at the top there, all those little blobs of paint, and so on. You get the network track, which is all the network requests that are made. That's very typical during page load. During sort of interaction performance traces, you might not even get any network requests, in which case we'll just hide this track for you. You get the insights toolbar. I'm not going to talk about that yet. That's a very exciting part of it, but we'll come back to that in a minute. And then you get the main thread, which was traditionally the typical part of this. And again, there's a lot of detail in here. There's a lot of different tracks. You can go into what JavaScript's executing, what your rendering pipeline's doing, what your GPU's doing, and that sort of thing. At the bottom are those performance metrics I talked about before. So when's the navigation happen? When's the LCP happen? When's your FCP and so on. And then finally, you get your details panel. So if you click on things, you get a lot more detail when it goes on there. The first problem that people have is using this. I don't know anyone that's used it in the past. Have you tried to do that? If you try and zoom or move your mouse, everything sort of moves in a really weird, unintuitive way. So if you've ever been scared about that, click this button. Actually, I'm going to switch over and show it in light mode. It's a bit easier to see here. There's basically two options. The modern option, which is the sensible option, and the classic option, which is just stupid. We haven't been able to change the default yet. I'm pushing for it. But some people are used to it. We don't want to annoy the old people who are doing that. But I do strongly encourage you to try the modern option. Basically means when you scroll, it scrolls. And when you shift scroll or command scroll, it will zoom. And it's much more sensible. So if you've ever been put off in the past, try that. We also have trace history. So you can flick back to that live metric screen by clicking the home button, or you can do that drop down. You can take several traces. You can try with those different calibration options. Try slow 4G, slow 5G, and we'll show you both the URL and the trace conditions it was done under. We didn't used to show this in the past. It's just like a nice small quality of life improvement there, so you can actually compare your two traces and say, oh yes, whenever I slow it down, it does get worse. Yeah, so as I say, moving around the performance trace traditionally was a little bit unintuitive. So we made quite a few just small changes to try and make it a little bit nicer. First of all, we're going to get rid of this insight side panel. So there's a little toggle at the top. You can hide that. You can show it again with that. As I say, we will come back to that. Ava's going to talk a good bit about that because we're very happy with that feature. But for now, we're just going to put that away and concentrate on the old traditional performance trace. So first of all, there's various zooming options. You can use the mini map at the top, and you can just actually zoom in. You can select an area that you want to look at, maybe it's where all the JavaScripts are doing. You can use, for the old school gamers of you can press WASDF to zoom in, zoom out, look left, look right. You can use your mouse, you can use those little bars at the side and do that. So there's a lot of ways to zoom in there, and say, hopefully a bit more intuitive now. We've also added this little line, so as you're moving around that mini-map at the top, you can see the blue line and see where it's actually going at the bottom. Small, as I say, quality of life improvements, but they just make it a little bit easier so you don't get lost as much. We've also added dimming to a lot of the performance trace here. So as you can, as you're clicking over bits, you can see in the mini-map, well, maybe you can't see that, but anyway, in the top left, you can see which bit that you're actually looking at in the mini-map. And then similarly, sorry, we'll come back to that in a minute. The other things we've added is breadcrumbs, so you can select a bit of the trace and say, I want to zoom in this, and that traditionally went out of sync with what you're seeing there, so that the screenshots didn't line up with what you're seeing. When you now click on that, zoom in, so it takes up the whole thing, so your screenshots now line up to your map. You can flick back and forth. Firefox, by the way, has had this for a while, but don't tell them we stole it from them. But it's just a nicer way of being able to zoom in and zoom out to the different bits of the trace. Going back to the dimming feature, quite often what you'll see is you've got your code that you care about and a lot of third-party code that you have no control over, whether that's frameworks, whether it's ads, whether it's our favorite Google Tag Manager coming in and destroying our pages. So you can actually dim out that code and say, I just want to concentrate on what the code that's under my control. That's not to say that third-party code isn't a performance problem. It often is. But if it's out of your control, there's no point in actually looking at that. Or at the very least, you should be able to see what performance problems are caused by third-party code and what performance problems are caused by my code. Similarly, you can also highlight it. So you can sit there and, as I say, that Google Tag Manager thing, you can see what exactly is it doing on that page compared to what my code's doing on the page. And finally, going back to that framework stuff, you might want to hide stuff completely. So the dimming is kind of useful, but if you're not going to look at your React hardcore internals and you just want to look at your function that's being called at the top, you can right-click, you can collapse those big, huge flame charts and say, I don't want to show this anything under. I don't want to show any instances of this function anywhere in the flame chart, or I just want to add this whole script to our ignore list and see that. And at the top, you can also set various sort of regexes and stuff like that to say ignore these sorts of things. Again, I just want to stress that that doesn't mean that they aren't performance problems. So be a little bit careful about hiding stuff that you're not actually hiding actual issues here. Okay, at this point, I'm going to hand back to Eva to talk about the more exciting performance insights.
Yeah, so all these changes Barry showed us are really useful, and I really wish he explained all of that to me a few years ago. Maybe I would become less scared of the performance panel. I hope you enjoy the little ride there. But the truth is, I did get scared of performance panel before. That's why I intuitively fall back to Lighthouse. How many of you use Lighthouse in your development workflow? Exactly. So that's why I think Lighthouse became such a popular tool, because it allows you to kind of take a step back and focus maybe on some starting points. Even if you know how to operate very well in the performance panel, you actually need a lot of expertise to know where to start. And Lighthouse gives you nice scores that allow you to, see the overall health of your page. And also, inside the audits, you get a lot of useful information about where to start your investigation. What Lighthouse cannot do, though, is to point you later on where are the exact fixes hidden in your performance trace that can help you make your site faster. So what if we combined the power of Lighthouse simplicity with the powerful tools we get in performance trace? Well, that's exactly how the Performance Insights sidebar was born. In the Performance sidebar inside, in the Performance Insights sidebar, you get very similar insights to what was previously presented in Lighthouse, and also they will be ordered in a way that shows which fix gives you the biggest wins in terms of performance. So very similarly to Lighthouse. And the insights that are kind of passed and nothing needs to be done will be marked as passed. This really gives you a nice way to focus on the most impactful things first. For example, here we have a longest contentful paint inside. It shows you, similarly to what Barry showed before on the live metrics, what was the element that caused the particular score for the LCP. But at the same time, when you focus on this insight, it highlights the important information of the main trace. So you know which parts of the main trace are interesting to you. In this case, we're looking into LCP phases, and those phases get overlaid on the main track. In a similar way, you can investigate things like layout shifts, render blocking requests, forced reflows, and many other. You can even see a tree map similarly to Lighthouse to go really in depth into your JavaScript bundle. Now,
yeah, and now we did a lot of soul searching with those Lighthouse audits. We combed through them all. We got rid of some of the older ones. We combined some of the other ones. We added some new ones. And we're actually bringing this stuff back to Lighthouse. So if you look at the latest Lighthouse, be it on page speed insights or your performance panel, this isn't working. Oh, there we go. You have an option at the minute to switch over to the Insights version of Lighthouse. It's fairly similar, but it's just slightly different audits and stuff like that. That's going to become the default over the summer, and then eventually we're going to get rid of the old audits. So you can go in there and have a look now and actually do it. And the idea is that if you run a Lighthouse trace and then go into the performance trace, you're not suddenly starting afresh and anew. You're kind of linking between the two, and you can actually see those. And yeah, it wouldn't be a tech conference talk now without mentioning AI again. So we've also added AI to the insights and to various other parts of the performance trace. So you don't know what one of this insight means, you can just have a conversation with Gemini and sit there and say, what the heck does this even mean? Barry might know what it means, but I have no idea, or how do I fix it, or whatever.
Yeah, so how does it work in detail? In particular insights, you get this little Ask AI button. When you click it, the context of that particular insights, together with part of your performance trace, will get passed to Gemini, and you can get an explanation of, what you can do with it. It works like this. You click on the button, the context is selected for you, and you can just ask the query.
By the way, those are just suggested queries. You can type whatever you want in there to have a conversation.
Yeah, we suggest a few of the ones that we find useful, but of course the prompt can be whatever you want, as long as it kind of relates to that particular query. And you get hopefully actionable advice of how to fix particular insights. It's especially useful for people that don't debug performance problems on an ongoing basis, or just looking for quick wins. And while you're looking into insights, you get a lot of other info about your page. And in particular cases, AI can be helpful in other panels too. For example, here we have the legacy JavaScript insight. In this particular insight, we see a script that requires our attention. It's flagged as having some problems with the legacy JavaScript. So when you click on the name of that file, you're taken straight to the sources panel. And in the sources panel, next to the script, again, you have this little SKI icon. You can click on it and ask questions that relate to that script. For example, what does this script do? Why is it present on this page? Is it safe to remove that script? Is there a newer version of that script? And so on. Very similarly, in the same insight, you can click the network icon instead of the name of the file. This way you're taken to the network panel. And in the network panel, of course, you can see all the details about this request. And again, you see the little SKI icon. When you click it, no. Well, when you click it, you're taken to the AI assistance panel, and similarly, you can ask questions, for example, how to make this this particular request faster, what headers are present on that request, and so on. It's really helpful with debugging.
Okay, I've got two last things I want to share with you in the performance trace, and then we'll get into the nitty-gritty and actually see this in action, because there's a lot more fun whenever you actually see it being used and doing it. First of all, is annotations. So this picture is about 10 years old, or 15 maybe. This is someone from the Wikimedia team, and they've printed out one of those big long performance traces, and they're going through it. They're adding post-it notes, and oh yeah, must look at this and have a look at that, and this is a potential problem and stuff like that. This is great. I'm not entirely sure it's the most sustainable or achievable way of doing this sort of thing. We don't all work in the same office and stuff like that, but we like the concept. So we added annotations to the performance trace. So you can go in there, you can double click things, you can highlight it and say, hey, this is something to investigate later, or why is this so slow, or what's keeping this sort of thing. And then you can save this trace, you can share it with your team, they can have a look at it, or just for yourself, you know, if you spend a lot of time analyzing something, you don't want to start again from scratch when you come back to it tomorrow. You can even highlight ranges of sections, you can link things. Here's where we're going to highlight a section and say, yeah, whatever, nothing much happening here, or something like that. And because it's the theme of the day already, we've also added AI annotations to this.
Yeah, of course, AI jumps in again, and if you feel particularly uninspired about adding a name, a label for a particular event, the AI will try to analyze the part of the trace you're trying to bring attention to and propose a label for it. You can try a few times until you're kind of happy with the result, or you can just overwrite it with your own words, of course.
That's helpful because it can analyze the thing and actually give you a sensible name for the function. Sometimes it can't. It's only as good as the inputs it gets, but yeah, it can be definitely helpful. And then the last thing is extensibility. So I know a lot of people have your own knowledge about your stuff, or you're using a framework. So we've built a new API where in your JavaScript code, you can add call outs to DevTools and say, hey, DevTools open, add this little bit of section here. The way it works is you make a couple of calls saying, this is important things, whatever. So it's kind of similar to the annotations, and it will highlight a bit of the trace and say, this is where hydration is starting. This is where I'm starting to do this. This is where I'm starting to do that. And then it will give you a custom track with those sorts of information in line with the actual performance trace. What's probably more exciting there is that we're seeing frameworks doing this. So Angular v12 announced this at Google I/O last week. Hi, Mark, by the way. So it's got that built in. You set ng Angular profile, I think is the directive you give to it, and it will automatically fill in those things, and you can see when Angular components are hydrating, whenever they're being run, and that sort of thing. So again, it takes the performance trace, which might be an alien language to you, and kind of puts it closer to the actual framework language that you might be used to there. So if there's any framework authors in the room, let's come and speak to me. We'd love to see this rolled out more. I'll show you how easy it is and that sort of thing. Okay, and that's pretty much it. So there's another quick video of all the things we talked about, including some of the things we didn't get around to. Okay, So whenever you're stuck, whether it's performance issue or other issues, you can now ask AI in DevTools. And hopefully some of you are less intimidated now about addressing performance issues and having a look there. So strongly encourage you, if you've never looked at the performance panel, to have a look now. I think it's easier for newcomers to come there. But I think we've kept the power for your hardcore performance engineers that aren't going to be lost there and going to find a lot of these things useful. We've a great documentation site that we spend an awful lot of time keeping up to date at developer.chrome.com/doc/devtools. And we've also our new DevTools series where we do a lot of YouTube videos about some of the new features that we're doing there. So we encourage you to check those out. But as I say, I think it's easier to see some of these things in action. So we'll try and we'll look at things. Does anyone want to volunteer their website? Come on, don't be shy. Anyone?
Also, if you have any questions, feel free to ask.
Oh, come on. Second? Mark?
Just a question for the live stream. Do we need a mic for people asking questions?
Oh, no, they're just giving the website. Market.ai? Smartly? Oh, I don't even know what Smartly is. What's Smartly? Oh, well, that's looked slow to load for a start. Okay. So here we can see I
think Smartly is sponsoring the conference, right? Be careful, Barry.
Oh, am I about to insult one of the sponsors? Loaded quicker the second time there. Let me just have a look. Have I got?
Okay, so what you can see is actually, well, you could see a moment ago where the live metrics.
Yeah, sorry. Oh, there we go. Well, actually, that's not fair because I just moved things. Second time it seems a bit faster. I think it's this pop-up cookie, the cookie banner that's taking a while. We can see that the real users are getting a slightly slower time there, and most of it is taking a while to actually render the icon. Have you got the clicker? Hold on a second here. We'll try and do something fancy. So just there. Ooh, it doesn't work that well. Where'd it go? Okay, so yeah, just at the bottom we can see there's a lot of time spent waiting for it. So it's got all the resources it thinks it needs to actually display this LCP, but it's just taking a while to do it. That's fairly typical with cookie banners. This is another thing that devs tend to do. We turn off that cookie banner because it's annoying, let's be honest, and we never see it again. Meanwhile, a lot of our users are coming to our site for the first time. They're getting that cookie banner, and that's what they experience as a slow website. So I'd say that's the biggest problem here on the LCP side. IMP is looking pretty good, even on mobile. If we switch over to mobile, it's slightly slower, but that's pretty good. CLS is not bad. Now, I did notice whenever I first loaded it, there was a bit of jittering going on there, again, with the cookie banner. So overall, I'd say your cookie banner is the main sort of problem on this website. And for a website with video and that sort of thing showing on, that's not too bad. But I would look and see if we can load that cookie banner earlier. Or the other trick is if you can break up those paragraphs so it doesn't show as the main one. But even then, it's still quite an annoying pop-up that people see. So whatever you can do to improve that. So I'll go in and show you some of the insights. When we do the performance trace. I'm an old man, so I'm going to flip over to glasses here for a second. Yeah, so as we said there, whenever you flick on these things, we automatically zoom in the appropriate part of the trace, so you don't need to move around there. Here we can see what this big delay is. You can go in and see what else is running. I see Google Tag Manager, usually a fun one that's doing this. There's an awful lot of script running here. We can see this is what it's taking to do to create the longest bit, which again is a marketing ad. This is render blocking, it's marking it in red. So that's probably the bit that's causing the biggest problem. So I don't know what RTP.js is, but let's see if we can, oh, sorry, no, that's the wrong one. Let's see if we can ask the Magic AI what it thinks. What does this script do? So never having seen this before, this could all go horribly wrong, but it will sit there and say, Primary, it's responsible for loading, figuring, and executing the marketing RTP functionality on a web page, including, okay, so it's basically the cookie banner and stuff like that. So even though I've not seen the script and it's minified and it's, you know, if I was looking at this myself and actually trying to figure this out, other than the name, I'd probably be guessing. AI is much better at actually doing this. So as a self-professed AI cynic, some of this stuff is actually quite useful to actually use this and do it. The other thing you see is sometimes old JavaScript snippets that you don't need anymore. What is this? This is an IE10 hack that you had to do back in the old days. Do you really need that anymore? So it can recognize frequent sort of snippets of JavaScript that people have on websites that they don't need anymore. Or you're polyfilling some old JavaScript functionality that's long been available in all JavaScript browsers. So yeah, I mean, that's kind of it. And as I say, you don't need to dig into this trace anymore. You can kind of use these insights, which will automatically pull you into where you need to look and what you need to look and see. So that's pretty much it, unless anyone's got any other website they want us to look at. Otherwise, we'll move on to questions. Sorry, somewhere over here first. Netflix.
Maybe you want to try to type it?
Oh. Careful, the leads there.
No hacking, please.
All right. Keep it safe for work now, please.
Yeah. Thank you.
This
The
bit.
bottom is very back.
Okay, so we flip back, and even though we were in this trace, the live metric screen's kept up to date. This is looking a bit scarier. Don't know if you work at this or you're just trying to embarrass your competitor. So here we can see that all of the metrics are having problems. LCP, which is traditionally the most difficult one, is taking about 3.5 seconds. Google recommends 2.5 seconds or better. This looks like time to first byte is taking a long time, so it's taking a second. So that's when you make your request before you even get the HTML back. So that is, you cannot do anything faster than that. So that's your minimum time. And a second is a bit longer than we'd really like that. Then it's taking 2 seconds to actually recognize the LCP resource and load it. I don't know what it is, but we can see, okay, so hidden behind this annoying cookie banner, this is what's taking a while to load. That suggests probably that it was not in the HTML, it was loaded by JavaScript. Maybe it's the carousel that loads the JavaScript and does that. So the more you can get to that HTML, is the better you can do that. CLS, I'm going to show you this if I can. We'll come back to CLS in a minute. I think the performance trace is still a better option for that one. INP, so it's taking 800 milliseconds. That's nearly a second. You're clicking on something, and for a second, you've no idea whether the browser registered that or not. So maybe you click it again, and nothing happens. You click it again, and suddenly that menu opens and closes 3 times, and it's really, really annoying. This is quite often more difficult to actually figure out what the issue is. So if we hit our slow down, and the best thing here, if you don't have field data to actually know what it is to just click around, try different things, try your typical user journeys, add to basket, check out, that sort of thing, and see what's slowing slow. Like when I sit there, maybe search is quite another one. Seems fairly fast, so yeah, I'd need to dig in a bit more to actually find exactly what the problem is, but maybe you as a site owner have a better idea about, oh yeah, this is the one we know that 90% of our users look through and do that. On the CLS side, as I say, if we do a performance trace, takes a couple of seconds. So there's a handy thing that we added in the last year where you can actually see the CLS issues. Where are we? Layout shifts. So if you hover over this, let's make this a bit bigger so we can actually see it. Oh, sorry, I need to get rid of that. No. Right. So these are the blocks of shifts happening. And as you do it, you can see, okay, something in that purple moved. I'm not sure what that is because I can't actually see it there. Is that something underneath? Oh, so that's probably the cookie banner loading. Maybe it's loaded with display none, and then something comes in there. So it will also, in the details area, give you, if you click on this, footer star inserted is the problem. So maybe the footer is loading, and then that's also fairly typical with client-side apps. You load the header, you load the footer, and there's a div in the middle which is loading your app, and there's no min height on it, so the footer's right up there, and then it moves it all down. So yeah, those are the ways that you can kind of debug CLS.
Daniel, we have time for one more, or we should wrap up?
Someone over there would quit? No?
Yeah. You can do one more site.
Name.com, as in N-A-M-E. Okay. Nail your business. Nail your name, build your business. So here I'm seeing that the biggest issue is INP. Now, some of the INP problems are cookies banner related. So you get your cookie banner, and as soon as you hit OK, it loads let's just say a lot for polite company of tracking things and stuff like that. Oh, that's not too bad. So that's normally a big issue, but that looks fairly good. So again, your best bet here is, oh, there. So as soon as I opened that menu, we saw we had a 240-second INP delay. Quite often what people do is they'll delay JavaScript until people actually click on it. And that's great for the first page performance load, but then as soon as you do it, that first click is actually slow. Didn't seem too bad there. 240 milliseconds is kind of just outside the good zone for us, but it can be an awful lot longer, particularly if you're in a slower network and that sort of thing. So lazy loading JavaScript is good. Lazy loading all JavaScript until you really need it means that that first interaction really gets that hit. So quite often, what a better pattern is to delay it, but then once the page is loaded and it's kind of calmed down, there's a bit more time to breathe, then load the stuff rather than wait for the user interactions to actually do that. Other than that, it's looking pretty good. We've green numbers, bit slower here, but that could be my own throttling and that sort of thing. But from the field numbers, we're looking pretty good. Cool. So I hope that was helpful, and I think we've got some time for Q&A now. If anyone does have any questions.
We have quite a few questions here. So first, give a round of applause for Barry and Ava. Most thumbed up question we have here is probably the most consistent question when it comes to AI in general and integrating it into our workflows is how concerned do we need to be about privacy, especially in regards to letting the DevTools go into our own IDEs, make code changes locally for us? Do we need a business license to prevent our code from being used to improve the AI overall?
So to use AI in DevTools, you need to opt in. And over there in the opt-in screen, you can read all about how the data is used. Generally, the processing happens on the server. So as soon as you send something, like your prompt in DevTools, it goes to the server. This might be concerned, especially in business setting. So you can control whether this feature is available for individual users through an enterprise policy. You don't need a business license to enter enterprise policy. Any individual user can set it up. So maybe the name is a bit misleading, that is called enterprise policy. But yes, you can disable this feature for privacy reasons. Right now, the queries, all prompts happen on Gemini on the server. This said, we also have now built-in AI APIs available in Chrome. They're still in experimental state, so stay tuned. Maybe there will be some good news for you soon.
Yeah, and we did look at the on-device AI is a natural answer to this sort of stuff, particularly for DevTools, which takes a lot of, you need a fairly large context window to gather a lot of information, whether it's performance trace or the details. They just weren't there yet. So we did experiment with that because we know it is an issue for some people. But at the minute, the server was proving much better and stuff like that. But it does mean that we're going to lose some people. But I do encourage you to check out whenever you link. There's a T&C thing written in non-lawyer speak that explains exactly what we do. We use it for, what we don't use it for. I think particularly in Europe, it's a lot more strict and stuff like that. So maybe it's not as big a deal as you do. But check those out. And I'm not a lawyer and that sort of thing.
Yeah, sounds good. Thank you. Another question we have here, we have time for a few here. So is there a way to integrate metrics analysis into these pipelines? Also, are there plans to support integrations with things like Playwright for collecting metrics?
Is this for the performance side, I'm presuming?
I imagine this is going to be regarding performance.
we're big into our field metrics because I think we've far too often in the past looked at lab-based stuff, and it is very limited depending on what machine you're running on, that sort of thing. So Lighthouse is a great tool, and it's one I use myself all the time, and it's good for spotting regressions. But typically, it only does a page load. You don't know what people are doing. You don't know what devices people are using, what networks they're on, what user journeys they're doing there. It's easy to make a lot of assumptions and things like that. So in Lighthouse, there is various budget tools you can check and make sure that it doesn't extend it, but you add a build step and suddenly your JavaScript increases in size and that sort of things. You can check those sorts of audits. But I think for the actual metrics themselves, field data is much better. Now, that does mean you can't see it until after it's gone live and been out there for a little while to gather some information and stuff like that. But honestly, like that is the creme de la creme. And hopefully with the Chrome user experience report, we're making that more available. So even those people who don't have a dedicated RUM solution can get some idea of what's going on there. So yes, it's possible, but not always the best way.
TBD. Okay. Great. Another one here is, can the LLM be changed? For example, towards a self-hosted one like Ollama?
Right now, no. We always talk to Gemini, and we also do a lot of fine-tuning of the stuff we send. The primary reason is, especially for performance, when you run a performance trace, this is very heavy load, and you need to be mindful of how you build your query to get useful results. For example, when you hit the SKI button in the insight, only basic information about particular insight is sent to Gemini. And then Gemini or AI agent, actually, in this case, is deciding whether it needs more information or not. It has ability to probe and ask your performance trace to deliver more information about things it finds interesting, about particular image or particular resource being loaded. That's why we limit it for Gemini right now.
I'd also say we're at early stages with all this sort of stuff. AI is very new for all of us, Google included. So there has been some talk about the stuff Ava talked about with the inbuilt AI in the browser. Again, that's Gemini only at the moment for Chrome. There's talk about how do we standardize that and how do we do it, or do your OS provide the AI or that sort of thing. So I think a lot of this is going to be changing over the next years. But at the minute, these early stages, we're sticking with what we know and what we do. And some of the other ones, like Gemini, at the minute, what we're offering is included. You don't need a subscription or anything. Not to say that won't ever change, but the minute that sort of thing, with some of the other models, you need a subscription. So setting up that model and that link is out of scope for the moment, but who knows where the future will go.
All the AI features are under active development and are in the experimental status. So we actually proactively seek your feedback. So anytime you try it and have, for example, a feature request for a different model or for a different mode or to support something that is not supported right now, please feel free to submit an issue to the Chromium project. It's really very closely monitored, and we're really happy to receive any feedback, positive or negative, from you.
Great. Let's do, I think, just maybe two more here. We had a couple regarding the annotations in the performance panel. I thought that was quite interesting myself. But questions we had around that was, is it possible to prompt Gemini using those annotations and those notes? And there's another one about, like, how can you share those across teams? I think there's mention of a JSON file, but can you prompt a Gemini regarding those annotations and those notes, and how can you share those across team members?
So at the moment, no. So you can do various things with AI. There's the insights we talked about, and you can ask AI. You can right-click on any of the trace bits and say, ask about this. That's kind of going to use anything that was used for the AI of the prompt anyway. If you're adding your own, hey, this is blah-de-blah-de-blah, JavaScript. No, at the minute it doesn't take that in there, I don't think. But that's an interesting point. If you're giving it information, then it would be good to pass that.
I like that.
Second?
I like that.
Yeah, so we'll take that up to the DevTools team. And sorry, what was there was one other question?
I think it was about shareability. So
yeah.
What you can do right now, you can download the trace and upload it to the Trace Cafe, which is kind of a browser for trace. Of course, other developer can also upload it to the DevTools, but you can also upload it to the Trace Cafe, get a URL, and share it with anyone on the team, and your annotations will be included there.
Yeah, so there's a download option. Sorry, I just lost the screen here, which will save it as a JSON file. You can go to trace.cafe, you can upload it, that gives you a URL. It's actually got DevTools built into it. It's really cool, so you can zoom and look through and that sort of thing. That's a great way of sharing things, and it will save the annotations there and do that. For those, again, corporate environments that aren't happy sharing those sorts of things, you can just download it, email it to your colleagues, save it in a group drive, whatever, and they can upload it and see it there.
Okay, so you're effectively able to like share a snapshot and still have that be fully like interactive and navigatable.
Yeah, and
Okay.
as I say, is there any chance of getting the screen back there for a second? Like that's where annotations really shines. So if I take this trace and I hit save, so you can save without annotations. If you're insulting your boss in their annotations and you don't want to do it, you can't do that. But if you save it here, we'll just save a JSON file. Trace.cafe, which is not an official product. Paul Irish, one of the DevTools team, created this. I think it's brilliant. So I then take the trace, drag it on here for a couple of seconds. This will give us a unique URL that you can share in team chat or whatever, or even what we get is people sharing it with us saying, here's a bug, hey, here's, and we're like, can you upload it to trace.cafe and do it? And as you can see, in this website, we basically have the full DevTools, so we can do everything that we want to do here. We've got the full insights with all the zooming capabilities and stuff like that. So if you've added an annotation to there, that will show there. So it's quite a nice way of sharing bug reports for the DevTools team, by the way.
Yeah, that's awesome. That's awesome. Then I think just the last one here. Given your relationships with Google, could you provide a free trial for Google Ultra AI for everyone at Future Frontend 2025?
That's not under the DevTools team remit, but yeah, we'll ask.
We can look into that.
Awesome.
Give stickers.
Perfect. Well, let's give up another round of applause for Ava and Barry for this great talk.
Thank you so much.
Thank you.
One more thing to note before we all head out for our first hallway session here. How we're going to manage the questions is in between each session, we're going to end up clearing the questions that are in the platform currently so that we can manage the popularity of the questions per session. So if you see your question go missing after that session is over, that's what happened. We're just kind of cleaning up in between sessions. So if we don't get to your question, please track down the speakers and ask them directly. I'm sure they'll be happy to interact and chat further about all of these topics. So with that, thank you so much for the first talk. We will be back here in just a little bit. Thank you.
tap it and we just need put everything first. Binary shapes will go faster.
Yep.
This one.
This one.
Yeah. So that's 6. No, nelonen vai kokeilla?
Kyllä.
Okei, no ei tarvitse nyt.
Movement has fascinated me since I was very young, and I
All right, all right. So now it's me. Oh, do we have echo or what? So we're just about to start. So if you can join us, that will help, because it's sort of boring to give a presentation to an audience that's not in the in the hall. So please join. I'm actually responsible for the program. So when I plan a program, I try to introduce content that you might not see in other conferences. So in my own style, and every time I design a schedule, I try to include some surprises. You might say this upcoming session is one of the surprises, but I think in a surprise in a good way, because hopefully it makes you think about yourself and where you want to see yourself in, I don't know, 20, 30 years. So from my perspective, even if it's not a technical session, it's maybe one of the most important sessions of the conference. Actually, where are my MCs? Yeah, so I'm doing the work of the MCs. That's not correct.
I was there with the people. Should we give people 1 more minute to Juho?
No, we start. Just introduce the speakers, and we start. And if the people miss out of the good session, it's their fault, not ours. So we go.
Okay. Welcome back, everybody. Our next theme is a bit more on a softer side. And our first speaker of this theme came all the way from our favorite holiday destination, Greek. His first time in Finland. And I mean, he's going to introduce himself. So let's give it to Yorgos. Yeah, sorry. Yeah.
Thank you. So when the break started, someone was looking at the schedule, and I think I heard them say that personal trainers sneaked into the conference and we need to call security. So hopefully they didn't do that. So I am actually an engineer. And like Juho said, you know, this is not the usual topic in a technical conference, but I think it's very important that we discuss it for a minute. So how many of you guys sit more than 6 hours? Just raise your hands. Okay, 7? Okay, 8? 9? 12 hours. There's one. Okay, so at the end, this is yours. So how I got here, you know, it's a similar. No, that's not the screen you should be looking at. This is more like it, except the settings. Okay, great. So let's see. Yeah, so yeah, that's correct. So, you know, I went to school, got a degree, I did a PhD, and, you know, you sit there a lot also. And then, you know, I'm 41 years old now. There was COVID in the middle. And why that it's important is because this kind of thing happened. Before COVID, I was exercising every day. I was working on getting certified on some fitness programs. And then during COVID, I got worried about work. I thought the demand would drop, but of course, demand exploded. And I took on too much work, basically, and that made me feel bad. So I stopped training and sat more, and I felt more bad, worse. I felt worse about that, so I started eating junk, trying to feel myself, feel better. So I gained weight because I was eating junk and sitting more and not training. And then I got low back pain, and I felt worse. So then I decided one day after 6 months of doing nothing to train again, and I got injured, which is, it wasn't the smartest thing I've done in my life. And then I got stuck in this cycle where I was trying to rehab, but to rehab I needed to lose weight, but I couldn't train, so I couldn't lose the weight. So that kind of vicious cycle of needing to do something but not being quite able to do it, was very stressful. And this is what psychologists call a downward spiral, where we have some thoughts, those thoughts create some emotions, and then because we feel that way, we start behaving some other way. And that cycle repeats itself and gets worse, the more cycles we go through. And in the end, it becomes quite difficult to get out of. So it's best to not get into that, to work the other way around. And while I was going through all that, I realized that, as I was speaking to my colleagues, to other people I met in conferences and meetups, I realized we don't really talk about that kind of thing, right? No one opens a conversation with, well, my back kind of hurts, and I haven't really found something to help me. It's usually about, well, React or Angular, or what's the hottest framework of the day, and how much coffee we're long slide, should be this one. We pushed code to the production yesterday without testing, and something happened. And I also realized that by the time I started feeling pain, whether it was my back pain or the injury I had with the knee, that was the last thing that happened in a long sequence of events. But we tend to associate, the final break with, with the whole situation. So it's not very different to say, having a bad culture at work, or not testing ever, and then, finding a really bad bug that costs us millions, right? So it's similar to this iceberg kind of metaphor, where, all this is happening as we go through every day. And then at the end, we get the pain and we go to the doctor. And of course, when I went to the doctor for my back pain, they said, well, we need to send you to, to have an MRI, see what's going on with your spine. I was like, okay. So I went, had the MRI, and then the MRI showed a dehydrated disc, and we'll see what that is. Does anybody know what a dehydrated disc is? Okay, one person. This will be useful too. And I said, okay, great. So how do I rehydrate it? Because it doesn't sound that good. Well, they said you can't. I didn't like that response. So I started studying more about what happens when we sit, and what do we need to do to not let that happen. So let's do a quiz. I hope this works, because I need to Alt-Tab into the browser, and I have the wrong window open. So just shout out what you think is influenced by what, especially when the first system is malfunctioning or dysfunctioning, right? So where should we draw arrows in this diagram? And it's fine if you don't understand everything. Just give me something. Fascia and muscles, okay, good. What else? Muscles and bones. So muscles affect bones, that's true. And joints. Yes, that's all connected. Yep. Metabolism, yes. To what? To muscles, okay. And cells. Okay, so cells, metabolism, muscles. I was supposed to draw the arrows, but it will take too long. So please remember what you answered. Anything else? Muscles and spine, yes. Spine is kind of a bone and a joint, so it's somewhere in the middle, let's say. What else? No, don't cheat. What else? That's it, right? Those are the obvious ones. All right. So let's look at what the research says. Please switch. Oh, I'm not in the presentation, that's why. All right, so we did the quiz. There we go. All right, so cardiovascular, right? So what happens with our veins and our heart and all that system? So our arteries are elastic, which means that they can expand and contract as the blood flows through them, and that's a good property, right? They adjust. Now, when we sit after 3 hours, only 3 hours, and most of us here, like I started at 6 because I thought, no one's gonna answer, like I said 2 hours. The elasticity is decreased between 2 and 4%. I'm rounding the numbers. And 1% decrease in the elasticity means 13% higher risk of heart disease, right? So it's a big deal. And basically our hearts have to work much harder when we sit to maintain the blood flow. So the oxidative stress, so if you've taken antioxidants, all that stuff, there's this process happening everywhere in the body, including the vessel walls. So the oxidative stress goes up, the blood pressure goes up, and plaque begins to form in the arteries, the plaque that makes us have a heart attack when it gets too much. And most importantly, we mostly think of that this happens to old people or people who are not healthy, but actually it happens in all of us. It doesn't matter if we're healthy now, this is going on. Metabolism. The muscles stop absorbing glucose, and the insulin response, insulin is the chemical that the body produces after we intake glucose, and that response is decreased significantly. And the signaling around those functions is also decreased. Then the LPL enzymes, which is, if you had a blood test, you probably tested your total cholesterol. The LPL is one component of that test, and it's basically the enzymes that break the triglycerides, if I'm pronouncing it correctly, break down the triglycerides in the body. So check this out. The LPL enzymes in the muscles get lazy, right? They stop doing that process. But the LPL enzymes that are in our fat storage keep working. So all the fat that all the food that we ingest becomes fat. And then the triglycerides alone are a problem because they go up 25 to 40%. So if you want to cheat on your blood test, walk for a few days before going to get your blood tests. And then inflammation goes up, the anti-inflammation goes down, and we are more hungry. This is all happening when we sit. On a cellular level, the mitochondria, if you remember that from school, those are the energy production centers of the body. Their capacity goes down, the oxidative stress goes up, inflammation increases. Who knows what gene expression is? Okay, so genes, you all know what genes are, the DNA and all of that. So they have some information encoded in them, and their function is to produce proteins that go and execute those things encoded in the genes. And we call that gene expression, right? Now, they took some people who were, fairly active, and we made them sit down for 2 weeks, probably bed rest, if I remember correctly. And they took samples of their muscles before and after. And what they found was that 4,500 of these genes, which is about 25% of the total genes in the muscles, changed their expression. So the average amount of change was 20%, but some genes changed more than 50. And the genes that were affected were that long list there. So energy production, glucose, lipid metabolism, what we discussed, the nerve muscle communication, pro-inflammation and anti-inflammation, oxidative stress, timing, and sleep. And just to make a note here that our bodies have a mechanism to do inflammation, because inflammation in some context is a useful mechanism, right? So it's not always a bad thing. Now, this change is measurable in as little as 3 days. So in 3 days, we can see these genes starting to change their expression, and they increased over the 14-day period. Now, if we check if we can go back, can we reverse this? They found that 85% of that change was reversible in 14 days, and then the rest in more than 30. And then for older people, and old doesn't mean 80, probably like 40 or 50, they reverse slowly or not fully. Joints. This is a joint there, probably the knee, I would guess, just on the two bones and without the actual kneecap. But the structure is always the same. So there's two bones, and then in the middle we have some tissue that acts like a separator between the two bones so that they don't hit each other, and obviously that would be bad. The issue is that there is no blood flow to the actual joint, especially the stuff in the middle, the cartilage. So the joint system relies on the circulation of the synovial fluid, which is some fluid that's within, like in the middle, and provides like cushioning. So we need to actually move our joints for that fluid to circulate and do the exchange of nutrients and waste, right? So the circulation goes down, so there's less nutrition for the cartilage. We produce less hyaluronic acid. So there's more inflammation, and the whole metabolic disruption that we talked about earlier, that influences the joints also. So it's no surprise that we found that the likelihood of pain in knees and hips is 1.8 and 2x for people who don't move a lot. And then if you're over 40 like me, then the risk, if you're sitting more than 7.5 hours, the risk of osteoarthritis goes up almost 50%. Spine, big one. So the whole problem with the spine is that we go from this posture where everything is kind of distributed, so some weight is taken by the lower part of the body, but also because of the angles and the way the spine is designed, which is an S curve, the tensions are balanced. But when we sit, when we have that hunch, the bones actually come closer to each other and they start compressing the material in the middle. And that goes up, the compression goes up 40 to 90%. And if you're slouched, it's almost 200%. So if we sustain that pressure over time, then we get the dehydration because there's less nutrient delivery. And it's just the beginning of those old postural changes that we know, the chest in, the neck forward, all of that. So let's look at, there was a study done very recently, I think 2022. I can't see, but somewhere around that, and they found that 73% of 9-year-olds have at least one bulging disc. And we'll see what that bulging disc is here. So on the left, you can see a drawing of a spine, and those are the kind of different states of disc degeneration. So on the top, you have a normal disc. When it starts degenerating, dehydrating, it looks like the second one. And this is the equivalent that we get from anatomy, so from dissection. And when it's bulging, it means the compression pushes the disc, the stuff in the middle, which is gel-like, I mean, a very hard gel, but gel-like, outside. And then over time, it can hit nerves and causes pain, or become herniated, which means that the liquid can start leaking out into the canal, which is even worse. And then, it can get really worse if the disc starts becoming thinner over time. And the worst case scenario is this here, where the bones come very close, and then the body actually builds extra bone to somehow protect it. That's the most painful. And you see that kind of last stage over here. There is some limited evidence that it also influences our, our brain and how we work in the central nervous system. We definitely know that our awareness of our body and what's going on inside it, our proprioception, goes down. And then because of the blood flow and the glucose and all of that, it also influences brain function a little bit too, which is probably why, when we take walks, we have most of our best ideas. Musculoskeletal, the muscle activity goes down 80 to 90% when we sit. So basically our muscles become weak and they shrink. Protein synthesis goes down, and there's almost 50% risk of chronic pain. Now, this is a fascinating part of anatomy is relatively new, and I'll explain a little bit why it's important. And it's this thing called the fascia, which most people will probably hear for the first time. It's all this stuff that exists everywhere in our bodies. And when you see the drawings in the anatomy books where there's a skeleton and some muscles on top of it, that's a lie. It doesn't look like that. It's drawn that way because as they were doing anatomy, they were cutting through all the fascia, because it kind of glues everything together, right? So it's this kind of matrix that exists everywhere, between the muscles and the fat, the nerves around the organs. It's literally everywhere. So what we know about it now is that it's a tension network, so it helps distribute the forces that exist within us, or when we pull something or push something. And it's also a sensory organ, so it transfers signals, and actually plays a big role in creating chemistry from force, right? So as it accepts force into that network, our chemistry adapts. And it's also very dynamic. So depending on how you load it, it looks a little bit like a sweater when you look at it zoomed out. This is a sort of drawing of how it envelops everything. It is literally over our whole body, right? So all the transparent stuff you see on this picture is fascia. Now, why this is important is because we initially thought that the body is a compression structure like this, right? So there's these big blocks just sitting one on top of the other, and somehow they can balance themselves out. But when they actually tried to rebuild models of the spine, they couldn't do it because the bones, the surface that the bones touch with each other is very small, so you can't actually make it stick without adding something like strings that you see on the side here. And this is not supposed to be an exact replica of what happens in the body, like the fascia is literally everywhere. But it just gives you an idea of the kind of thing you need to do to make that stand. And this is, by the way, 12 meters high. So it's a big construct. So we're changing our ideas about the muscles and the tension and how that behaves in terms of keeping us in a posture. So initially we thought, oh, these are just levers, right? So we have a lever here on the elbow, and this just does that. It's not true. This is our current understanding of what's called the anatomic trains, and it's a model that has a lot of scientific validation to it. And you can see, for example, that on the back here, and this is a line that suffers a lot when we sit, starts from the top of the head over here, so all the way from here, goes down the back, down our back with these two, round muscles here, then through the hips, and then goes down to the legs and finishes at the front of the toes, right? So I don't know about you guys, but I found this amazing when I found out about it. Now, what happens with the fascia when we sit is that they become dehydrated, dense and sticky. They have this glide property, which means that if you pick, your skin here, you can move it, right? That's a property of the fascia, because the fascia connects your skin, the fat underneath it, and the muscle underneath it. But normally it can glide like this, which means we are able to move in many ways. When we sit, it becomes really dense and sticky, and it starts having adhesions, which means it kind of becomes like a ball. And that's very difficult to break. And it also loses its ability to take force from any direction, right? So if we constantly load the fascia in one direction, it changes its shape to support only that direction and cannot respond so well in the other directions. And a very common example is, don't you love these drawings? They always have really great butts and no cellulite, and they're perfect, right? So anyway, we have a lot of fascia here that's very dense, and we found that when we sit, it actually thickens very much, and that makes us be stiff here. There's not necessarily pain, but lack of mobility. So let's go back to our quiz. Please forget the cheater over there from the speakers. But as you can see, there's arrows from everything to everything, right? So everything interacts with each other, and it has an effect on everything. So this is a kind of shift. So we're ending up with this. Movement is required for our body's chemistry to work. This is, astounding to me. Now, do we have any Rust developers in the room? Okay, good. I can make this joke. So, rest is rust, motion is lotion. Okay, so remember that. Now, as if all that stuff is not bad enough, our body actually adapts to what we do, not what we would have liked to be doing, right? So ideally, we would want our body to just work to keep us straight and, beautiful. Unfortunately, it doesn't work like that. Anytime we do something repeatedly, our body goes, okay, this is what we're doing, so I need to make this really efficient, really cheap, in terms of processing power. So it starts to lay down more structure to support that, habit. So for example, this is the most common adaptation, the tech neck, they call it, which pisses me off. And you see that, the neck has a really bad angle here when it should be like this. And this is a photo I took from an osteopathic website, I think, where they say, well, we can fix this. But look how they're only talking about bones, right? They're talking about X-rays, and there's nothing about fascia. There's nothing about the muscles, and check this here, right? Check the angle of all the meaty stuff here and all the meaty stuff here. The bones cannot, support themselves on their own. This is all a system, but unfortunately, a lot of these professions don't talk to each other, right? So they all have their own models and they work within those, which is not that different to what we do. We have React and we don't talk to the Angular people except from a distance. And, we often argue about it. Then they're very similar in that sense. So basically, the point of this is that over time, if we sit too much, we become chair-shaped. It's not a metaphor. This is literal. And to add insult to injury, I don't know if you guys know that expression, I love it. It gets worse with stress. Why? Because we have these primal reflexes, right? And this is a photo of a guy who's standing there and he doesn't know it, but someone is about to shoot a gun behind him, right? Not at him, but behind him. And when the sound goes off, when he hears the sound, he goes. That's a primal response to any threat that is supposed to protect us, right? So he's covering his neck and his soft bits, his heart and the belly that's completely unprotected. And over time, if we experience a lot of stress that we do not recover from, we get this. And can you guys see colleagues of yours like this, right? Not as extreme, obviously, this is a drawing, but we can all see this, right? You've seen this somewhere in the tech world, and hopefully not in the mirror. And I used to be a little bit like this, like I've corrected a lot of these things. So very impactful behavior sitting, right? So we see changes from within the first 24 hours. Within 30 days, there's some of that is becoming, is starting to become more permanent. And then, if we do it for months or years, then, we really need to work to reverse it. All right. So what's our next move? You get the pun, right? What's our next move? Okay. So every time I kind of talk about the subject in in a social environment, there's always a response. Oh, I know. I have a standing desk, or before I go to work, I walk for 20 minutes, and I always go, that's great. I really like that you have a standing desk and that you walk for 20 minutes, but unfortunately, the research says that this is not enough, right? So even when we stand, yes, our muscles work more. So you can see there's like 5 to 10 times more than if we're just sitting. That's great, but actually it doesn't improve our health markers. And we kind of have this this idea that if we're doing this one thing, that's going to be enough. So some people will say, I walk. Other people will say, I go to the gym, and that's fine, right? So I'm doing that. What we're actually finding is that we cannot do just the one. So we can't just break the sitting and expect for our health markers to improve. We also need to do moderate to vigorous activity. We can't just sit all day and do moderate and vigorous activity at the gym or wherever it is that we do it and expect to undo the 8 hours of sitting. Those are two separate things. And there's very recent research to support that. So is anybody getting a headache by now? No? Okay, I was. This is what I'm ending up with. This is what I think we need to be doing. And it's, it's from my research as well. I will say which ones of these ideas are my own and not supported by research. So, before when it came to sitting, I was trying to teach myself to be, as still as I could, and thinking that this would just allow me to be more productive, right? So I kind of punished myself for moving around or getting up too much. And now I'm thinking, okay, we need to stand as much as we can, and then we need to get up and move every 30 minutes, which is actually a nice threshold because at around 55 minutes, we have evidence that our focus starts to drift anyway. So we might as well get up and get the physical benefits from it. When it comes to posture, we have this idea that someone has a good posture or a bad posture, but we need to remember that a posture is a moment in time. It's a photograph. And when our posture starts to break, we need to get up, right? That's our body's signal that I'm not starting to feel good. Things are happening and you need to move around, right? Remote work. I have had some disagreements in the past about this. And most people say, well, I don't want to commute. I gain all this time by not doing that. And I'm like, that's amazing. That's great that we can do that. Not every profession can do that, but most of us actually did that when they gave us remote work. So we got up from the bed, sat on the computer, finished our work, then sat on the couch to watch Netflix, and then go back to bed. So if you are working remotely, use that extra time to walk and exercise. When it comes to exercise, we also have this idea, well, it's not an idea, but we're all drawn to the exercise, the type of exercise that makes us feel good, right? The one we like, the one we're good at, and it makes us feel successful, and that's natural. But actually, we need to thinking about more about the exercise that we need based on what we have been doing. And we also think of sitting as not doing anything, right? It's not something that we need to recover from. It's like if we go for a sprint, we kind of understand that we need to stretch afterwards. But when we sit, we're like, well, I was just sitting, like I wasn't doing anything. But in actual fact, seeing all that, we actually need to move after sitting. Like that is the recovery from the sitting period. And this is a model of how to think of the activity over time that I got from a program called TACFIT, which I've studied. And what the founder of this program noticed is that if we kind of follow this wavy pattern of changing through intensities with no intensity being just mobility work, and actually, so let's try this because I've been talking about a half an hour and you guys have been sitting. So try this with your wrist, okay? And we're only gonna try one wrist because I want you to notice how you're gonna feel with the other wrist. So just, use your index finger and just grab it with the other one. And then just move your wrist up and down. Okay, and then side to side. And I'll make it a circle. And go the other way. Okay, and then just do this like, imagine you have a glove and you need to put your hand through it, and just do that. Okay, so we did what? 10 seconds of this exercise. How does that feel? How does this wrist feel versus your other one? Just shout out. Better? What? Looser. Okay. Well, there was something in the back. Anyone else want to share their experience? So, it doesn't take a lot, right? We just need to just help our joints a little bit. And where's my clicker? There it is. So this idea is that on no intensity days, we do some mobility work. We just move our joints, like literally no intensity. Low intensity is some form of compensation. Compensation means that we are compensating for whatever activity we've been doing all the time, i.e. sitting. So this is some sort of stretching, yoga, whatever you feel more comfortable with. And then we have moderate intensity where we work on technique and strength of some skill. Could be weights, could be body weight, could be really anything. And then on the high intensity day, we work on volume, which means we go fast, but we go as fast as our technique can hold it, right? So for as long as we can do the exercises well, we give our heart a good workout. So if we look at this chart that I made up, and on the x-axis, you have structural requirement. So how much structure does your body need to be able to do an activity? And then intensity on the y-axis. We need to fill in the gaps, right? So whichever quadrant your favorite activity is, you need activities from the other 3 quadrants too, ideally, right? So these are some examples. Yesterday, I found out that there is a thing called Frisbee golf that you guys love here. And that, along with walking and mobility and stretching, is on the low structure and low intensity. And then on the other far right side top is something like CrossFit, which is very intense and very a big requirement on structure. And something like acrobatics and ballet is probably on that end, but lower. Then we have hiking and running. Obviously, it depends on how fast you're doing these things. So, it's different if you're jogging and if you're doing sprints. Swimming, again, because of the amazing variability that it can give you. So you can go ultra slow, and that's going to be a low intensity activity, and you can go fast, and that's going to be a high intensity activity. But in terms of structure, the water shields you from doing anything too stupid. And yoga is probably there. Depends on the kind of yoga, obviously. So if you're just doing breathing exercises like pranayama, it's all the way over here. If you're doing Bikram or something, that's all the way over there. And the point is, there are so many modalities that you guys can explore and practice and just become interested in, right? Not everybody has to do the same thing. You just need to find the one that suits you best. And then weights also have a very big range, obviously. At the bottom left, you have machines. I don't recommend those because you also are asked to do movements that are very unnatural in some cases. And they also teach the body to isolate, which is not what we need, as in our industry especially. And on the far right, if you're doing something like HIIT with weights, that's obviously intense and requires a lot of structure. Anything I missed and you're wondering about and you want to discuss? Cycling. Again, I would put it in near this axis because also like swimming, the bike kind of prevents you from, like it's a very controlled activity. I mean, unless you're doing, jumps over cliffs and that stuff, it's another thing. And the intensity you can vary depending on the, the surface you're going on and the steepness of it and all that kind of thing. Anything else? Yep. Martial arts, that's a good one. I don't have a lot of experience with martial arts, so I was hesitant to put it there. I would say martial arts are good. Of course, it's a huge variety, right? So it's different if you're doing taekwondo or like judo, right? So judo is very low intensity in some ways. Taekwondo can be very, or like kung fu or something. But what I like about martial arts is that they have a level system and you can't jump levels. So you're always working at the level that you should be, ideally. And this is part of this, what you should take from this chart, that if you're only doing walking right now, don't go to CrossFit now, just do some things in the middle, and then, maybe over time you can graduate to that. But, take it a step at a time, right? So keep away from injuries, just keep yourself healthy. Entertainment, this is a big one, right? Because we get off the chair and then, like I said, we go to the couch and we watch Netflix or we play Call of Duty. I don't know, maybe it's better to, walk in nature and, maybe go out paintballing if you want to shoot stuff, which, I highly endorse. And maybe socialize, there's a million types of different dances you can try. I know that's weird for us engineers, but you'd be surprised. And we also have this idea that, we have this split that like there's our, office self and non-office self, and we need to break that up because we can't afford to be active only in one of them. We need to be active in both of these sort of personas. And, maybe we don't talk about Claude and ChatGPT and vibe coding only. Maybe we start acknowledging that we have a body and we kind of discuss, what's helping us, what's not helping us, all those things. That's the real DX, right? That's our actual experience in life. So, don't wait to go to the doctor when the pain arises. Take some action now. It's much, much easier. Just, pretend you have a Kubernetes cluster and you just need to tinker with it all the time. And if you are feeling overwhelmed, as I was when I got injured and I was like, oh my God, I gotta lose all this weight and I can't train, and I just felt so bad about it. But again, there's metaphors everywhere. We're doing this agile thing, but why are we doing this agile thing? Because we tried some other things that said, okay, let's start by imagining everything, and then, from that imagination, going to take some action, and didn't work out that well because, things changed too much. So we said, okay, let's break it up. Let's do a little bit and then take some feedback and then, do that over and over. And hopefully we build some velocity. Then we go faster. Then we are stronger. It's not that different to stacking habits, right? So we, just start somewhere that you feel comfortable, that you feel you can do it, that is achievable. Then do it, feel good about it, that you've done it with the benefits and because you did it and you know that it's good for you in the long term, and then just add another thing and another thing and another thing. And if you do this, then you can expect to be more energetic. You obviously will be more healthy and you will have less discomfort. I mean, how many of us at the end of a working day, especially if you have a release, feel achy all over, without actual pain necessarily, but just really kind of stiff. Yeah, so it's quite a common problem. And that will help you be more productive. That is the actual productivity hack, not sitting too much. So, people ask me what do we need to be doing? I say, it's all simple, it's all understandable, there's no high complexity here. But it's very challenging. We have to change our ways, and people historically are very resistant to that. But it's also very important. It's imperative, I would say, that we start doing this. I was expecting lots of laughs with that one, but okay. All right. So just closing here, I just want to say one thing about this project that I'm starting. It's called stateofhealth.tech. It's like the Stack Overflow survey that you all know about, which asks us about our favorite technologies and the technologies we use, and our salaries and all of that. And we have so much data there, but we don't have much data around these things, right? It's all going to be anonymous right now. It's only a waiting list. So you just fill in your email and I'll let you know when the survey is open. And the idea is to start collecting some data that we refresh every year, just like the Stack Overflow survey, and we hopefully draw some attention to these issues and how common they are. If you'd like to follow me, that's my LinkedIn. And before I leave, I want to show you this video because all it takes is one person, as they say, hopefully. No? Why is it's not playing? What's that? Yeah, I swear I tried it. So I did test before pushing to production, but it's not cooperating. Okay, let's try in the browser. I know, right? You gotta live on the edge.
If you've learned a lot about leadership and making a movement, then let's watch a movement happen start to finish in under 3 minutes and dissect some lessons. First, of course, a leader needs the guts to stand alone and look ridiculous. But what he's doing is so simple, it's almost instructional. This is key. You must be easy to follow. Now here comes the first follower with a crucial role. He publicly shows everyone else how to follow. Notice how the leader embraces him as an equal. So it's not about the leader anymore. It's about them, plural. Notice how he's calling to his friends to join in. So it takes guts to be a first follower. You stand out and you brave ridicule yourself. Being a first follower is an underappreciated form of leadership. The first follower transforms a lone nut into a leader. If the leader is the flint, the first follower is the spark that really makes the fire. Now here's the second follower. This is a turning point. It's proof the first has done well. Now it's not a lone nut and it's not two nuts. 3 is a crowd and a crowd is news. A movement must be public. Make sure outsiders see more than just the leader. Everyone needs to see the followers because new followers emulate followers, not the leader. Now here come 2 more people, then 3 more immediately. Now we've got momentum. This is the tipping point, and now we have a movement. As more people jump in, it's no longer risky. If they were on the fence before, there's no reason not to join in now. They won't stand out, they won't be ridiculed, and they will be part of the in crowd if they hurry. And over the next minute, you'll see the rest who prefer to stay part of the crowd, because eventually they'd be ridiculed for not joining. And ladies and gentlemen, that is how a movement is made. So let's recap what we've learned. If you are a version of the shirtless dancing guy, all alone, remember the importance of nurturing your first few followers as equals, making everything clearly about the movement, not you. Be public, be easy to follow. But the biggest lesson here, did you catch it? Leadership is over-glorified. Yes, it started with the shirtless guy, and he'll get all the credit, but you saw what really happened. It was the first follower that transformed a lone nut into a leader. There's no movement without the first follower. See, we're told.
So let's start a movement, guys, okay? Thank you.
Thank you, Jorgos. I think I'm doomed. But so are you, because we are not having a break now. Our next speaker comes from a less exotic place, at least for us Finns, because he comes from Kirkkonummi. He's yeah. No, it's not worth. No. It's he's talking about balancing between mental and physical work, and you know, when people from, for example, US come to Finland, like Daniel, and work here, they really appreciate like work and life balance. And this guy missed the memo because during daytime he's a developer, and during nighttime he's a lumberjack. So he does not know what work and life balance means. But yeah, are you ready?
I'm ready.
Okay, let's give it up to Olavi.
1, 2, 3. Sauna, that's the way to test the mic nowadays. So I'm from Finland, as you heard, and you probably hear it from my accent as well. And I made this really big mistake of having the first word in my title as a word that I can't pronounce. So if we can get my slides visible. Do I need to do something? Let's see. Mirroring.
Okay, this is a blessing because I just realized I forgot to tell you that if you have any questions, we're going to have a Q&A after Olavi's talk, and you can send your questions to clipper.co, so cliper.co, and use FF25 code.
All right, now we have the slides. So yeah, the title of my talk, I can't pronounce the first word. Verse something. You can read it from there. As we also heard from George's, and we know everybody probably feel it, that working on the IT field is quite draining. Also for our body, but also I think mostly for our mental health as well. I hope this works at some point. Maybe we need to switch the cable. So do you ever feel frustrated and feel like this person on the screen while working on the IT field? And especially, how many of you have to work with JavaScript? How many of you would like to work with JavaScript but are forced? Okay, some people would like to work with JavaScript, but yeah, not many people like it. And especially while working with some dependency issues with NPM or debugging some difficult to find bugs, and working with, or having to work with the users who mostly don't know about tech, and they're always stupid. It's always the user's fault. So it actually sometimes makes, at least myself, want to just scream out loud and just shout in the void and move somewhere and start farming. Has anybody thought about starting farming? Yeah, I think it's quite common. Or move somewhere remote location by a lake and just live there. Disconnect completely from the internet and all the devices, and especially the AI, which is probably taking our jobs. So yeah, that's how I feel about tech. And that's why I wanted to just start my chainsaw and go out after work and cut down trees. So yeah, that's what I do when I get frustrated. So hello, my name is Olavi. And I'm the branch manager at Iltametsuri Oy, which is my company. And for the Finns, it's funny because the name means evening lumberjack. So I'm the branch manager at my lumberjack company. And that's one of the funniest things about being self-employed, like running your own business. You can just choose your title yourself. You don't have to get a title. So I'm a freelance full stack developer, and I'm currently in a super lucky situation because I'm a full stack developer. So I love working with the backend stuff and all the AWS and caching and CDNs and performance and backend of the front end, so Next.js and stuff like that, and then all the way to the front end, even performance and accessibility. But the one thing I hate is CSS. And I'm in a super lucky situation because in our team at the moment, we have one person who hates all the other stuff and loves doing CSS. So quite often I'm doing all the, if I'm doing a feature, I'm building everything from APIs and everything so that it works, but then they take care of the CSS. So I'm super lucky. So I'm a part-time lumberjack as well. So at the moment, I work 3 days a week as a consultant developer, and then 2 days a week, plus sometimes weekends and evenings as a lumberjack. I'll tell a bit more about that soon. And I started my own business in 2019. And this is literally me. So on the left side, you can see a picture of me when I'm working as a developer, debugging some weird issues and like scratching my head and looking tired. But then on the other side, you can see me working in the trees. So with the trees, and it's kind of like almost like therapy to me. And you can see some videos here about like how I climb trees and like also post content on TikTok just for fun. I got something like 6.5 million views on one of the videos, not this one, even though I think this one would have deserved more views, but the algorithm, you never know how it works. And a small disclaimer here. I'm not at all a perfect example of work-life balance and the stuff I'm talking about here. But I'm just gonna tell my story. And starting from 2017, or actually starting 2015, I started as a summer employee at Futures, which is a Finnish consultancy here in Helsinki, or like the headquarters is here in Helsinki, or we are in Espoo now, but anyways. And then since 2017, I stayed there full time, and also graduated while working at Futures in 2018 after studying here in Aalto University for 7 years. So it was nice to get it done as well. Yeah, and then I started my side hustle, mostly as a joke. Just, yeah, it was a joke. Yeah, and then it grew later. Then the corona happened, and so it was 2020, and we were super busy at work. So I started working way too much. So then back then I still was an employee, and I would work like 5 long days a week, and like then after a work day, after sitting on my computer at home for like 10 to 12 hours, then I would move to my couch and watch TV or play with my phone for the rest of the night, and then just go home to sleep. So actually, for me, it was really a blessing to get more gigs for my tree cutting gigs. So in 2020, because I had just started the company, so then I started slowly getting more gigs. At first, it was like just for friends and family, and yeah, it was difficult first to get actual paying customers, but then I started slowly getting more and more customers. And then by the end of 2020, or in the autumn after a large project, and I was probably quite close to getting burnout, but luckily I didn't get, so that was good. So then I switched to working just 4 days a week, like working just 4 days a week, plus then working on the tree cutting gigs the rest of the week almost. And then ended up jumping into full-time entrepreneurship in 2021. So then I switched to being a freelancer like a developer for 4 days a week, and then later on switched to 3 days a week. Yeah, that's like how it started, and then I want to tell something I've learned about all of this stuff. So the first thing I've learned is that running your own business, it's actually quite fun and interesting, but it's not easy. Like, it depends what kind of business you run. If you just work on the IT field and you're like just a freelancer, you get a long-term project. And basically, as we have this discussion in Finland ongoing, that are you really an entrepreneur if you just work in like freelancer and you have a long-term project? So yeah. But when you actually have to talk with the customers and sell your services and send quotes and stuff like that. One thing I think is important is to focus on your core business. Focus on what you can do. What's the main source of revenue, and then just outsource everything else, like accounting, and also in the tree business, I outsource everything that I don't want to do myself, such as like taking out the branches. So I just like pile them up in a pile, and then someone who has a truck for that, they just come and pick them up, and taking care of their stumps, grinding them. I don't want to do that myself. So I think that's really nice, because then I can focus on my core business. And I would probably do that as well if I would start a actual like business inside IT. Now I'm just selling my hours, so it's a bit different. And I would argue that there's no competition, or like, of course there is competition, but I don't want to see anybody as my competitor in a negative way. I want to see them as like potential cooperators. So I'm trying to gather this like huge network of companies and cooperate with them, and then because of that, I can, even though I'm like one-person company, I can do larger projects and gigs. And it almost comes without saying that as an entrepreneur, you have a lot more freedom than as an employee. So that's like one of the biggest things I love about this, being like full-time entrepreneur, because then there's nobody who can tell me that, okay, you have now 30 days of holiday this summer and stuff like that. So I went I had a 5 weeks vacation in Australia just now during the Christmas. But then again, for my summer vacation this year, I might have a bit shorter, because as a business owner, I just check the company account balance and decide based on that how much vacation I want to have. And of course, it comes to your project and customer. So I'm super happy with my customer now. It's super flexible, and we have stuff to do, but not too much stress there. And it takes some time to build a good customer base. So I see it now, because now I have been running the business for soon 6 years. So now it starts getting better. Like I get returning customers from even back in like 2020 or 21, and that's super nice, because the returning customers are the best customers you want to have, because then it's most probably, if they contact you again, they will accept your next quote as well. Yeah, and then some more lessons learned. One of them being that you can actually get rid of the fear of heights. So even though I started climbing trees and working in the lift, taking down huge trees, I had a quite horrible fear of heights. But then after a while, after maybe a couple of years, I realized at some point that, okay, when I'm climbing up a tree, I don't fear that I will die anymore. So that's a nice thing, because actually in the beginning I wouldn't sleep horribly before a gig, because I was like scared of death, and like I would see nightmares about falling down from the tree. But nowadays it's better. Marketing is quite easy to get started with, and because my area of business with the tree cutting is quite a small niche, so it was really easy to get started with Google Ads, for example. It was quite easy to get some contacts from there with a really small budget. I think I started with something like €2 a day and still got some value out of it. But then again, marketing, it's an easy way to waste money. You can like literally spend thousands of euros in Google Ads or Facebook Ads or wherever if you just check the recommendations, because of course Google Ads and Meta Ads, they always recommend you that, okay, increase this budget so that you will get more clicks and more contacts. So I ended up spending a bit too much on marketing. So now I've slowed that down a bit. Yeah, and one thing that I've learned is that a good balance between like working mentally with development and then physical work with trees, it actually gives me energy. And also recently this year, I started playing more hockey. So this winter I played like 2 to 3 times a week hockey. And previously I thought, okay, I was always so tired, I couldn't go play hockey in the evenings. But then when I started going there, actually, I realized that it actually gives me more energy, because when you do physical activity, then you maybe sleep better and recover from sitting at your desk. And one thing I've learned about myself, which is kind of weird, is that I love doing sales. So going somewhere, talking with the people, trying to sell them tree cutting, and then always trying to upsell, sell more services. And it's actually fun and interesting. And yeah, some similarities between like working with trees and in development, which like they're completely different fields, and like one is physical work and one is sitting at your desk. But there are similar challenges in both fields. One of them being communication. I think in dev projects, it's like one of the most important skill to have, good communication, and one of the most important things to actually focus on is communication with the team, with the customers, with everything around the project. And it's the same in tree cutting. I need to be contacting the people and agreeing on schedule and agreeing with my contractors on the dates and stuff like that. So communication is crucial. And one thing that annoys me a lot is that sometimes the customers don't know what they want. And this happens quite often in the IT field, but also in the tree business. So it's annoying to go somewhere and then look at the trees, and then they haven't decided which trees they want to take down, and they start arguing. The wife and husband start arguing about it, and yeah, I don't want to be there. But it's also quite often in the IT projects that the customer doesn't know what they want, or they don't know what they need. So then you have to help them. And estimation is super hard. How many of you have to like all the time do estimations for stuff you work on? Oh, I'm sorry for you. It's a waste of time, and it's difficult. You will never get it right. But in the tree business, I always try to give a fixed price. So then I have the risk. So I'm starting to learn it, but there's always so much uncertainty, and it's super difficult. So sometimes I just work on an hourly rate for the customers as well in tree business, but it's not that profitable. So it's best to get a fixed price that is like, and then if you're lucky, it's your estimation is okay. And teamwork is essential, and it's important both in tree cutting and in development, and nobody should do anything alone, I think, and especially in tree work, because you can die. So I normally don't do anything alone. I always have somebody with me, and most of the times we have a bigger team on a gig. There's some more similarities. One is that the feeling of success when you successfully launch something. So that's the best, I think, the best feeling when you have been building something for, let's say, a year, and then you finally switch the DNS and you launch something to the public. And then if everything works, that's the nice feeling. But most often you have some bugs, and then you fix those quickly, and then you continue having it in production. It's super nice feeling. And then when you start seeing the numbers go up and get some feedback from the users, and some positive feedback as well, that's a really nice feeling. But also in tree business, when you climb up a tree and then you cut down the top and then you launch it down and it lands exactly where you wanted it to land, that's the best feeling as well. And then sometimes you're like super nervous about taking down a tree, and the best feeling is that quite often the customer is actually nervous. I'm not nervous. I know what I'm doing, but the customer doesn't dare to watch. And then when I cut down the tree and it lands exactly where I wanted, that's a really nice feeling. And I think in both fields, you need to stay up to date and always learn more, especially now in like development because of all the AI development. If you think about it back a couple of years back or something, it's crazy what has happened now in the past years and how everything has been changed. Basically, we don't maybe see the change that much yet. At least for me, it has mostly changed how I write code. So basically, I don't write code anymore that much. I of course read code and fix it, but like it has changed a lot. So you need to stay up to date, and this is one of the reasons. Even though I would love to maybe take like a break from the dev world and just do tree cutting for maybe like 6 months, but I don't know if I want to do it, because then I would maybe fall out of the wave. So it's important to stay up to date and learn all the time more. And you can learn more by observing what the others do. Especially in tree business, I'm always like watching what the others do who are more experienced than me, and they quite often like to tell their tricks and tips to me. So that's super nice, and that's how I actually learned how to climb trees. I never got an education on it, because you could go to this arborist school, and it would take like 2 years, and then you would learn there how to take care of trees and climb trees. But I don't want to spend 2 years on a school, because I can just do it by learning from others. And then it's important to learn to do it safely. Yeah, so that's almost it. So my conclusions and my recommendations is for you, everybody, is to try out something else on the side of your work, basically. So it's a really nice idea to just test out something like I did. I just started the company. You don't necessarily need to start a company, but just try it out. And then if something works, then focus on it, or like invest on it. And it's nice to have a bit of variety, not just working 5 days a week on your desk. And being an entrepreneur, it's quite interesting. I love it, but it's not super easy. And yeah, you can get some energy by balancing physical and mental work. At least that's what I experience. But it doesn't need to be work. You can, of course, do some exercise and sports and stuff like that. And yeah, don't forget to sleep and exercise well. Of course, that's super important. And that's something I also need to focus more on, like doing the exercises. I'm going to actually run a Helsinki half marathon this year, but I haven't been running that much, so I need to start exercising for that. And not to mention a healthy diet, which, as you can see, I'm not so good at actually, but yeah, that's important as well. And you can follow me if you are interested in my tree cutting work and or other work. So in Twitter, I mostly tweet about tech-related stuff, and occasionally in Finnish, but I try to keep that in mind that my audience is mostly international. And then you can follow my company on TikTok, YouTube, and all the platforms. and there I post some funny videos and pictures from my gigs. Then my company website, which is designed by me, so it's ugly, but it works. It's a super high performance website. It's just HTML files. That's the fastest you can go do. It's HTML and one CSS file, and it used to be no CSS file, just inline CSS, but then I wanted to export that into a file. And then also my blog, which is quite interactive. I should probably start blogging more, but that's also a static website. So I love like fiddling around with performance and building as fast websites as I can. But then in the reality, in the real world projects, you always have these like analytics and ads and stuff like that that ruin everything. So that's annoying. But yeah, thanks.
Thank you, Olavi. We're going to have quick Q&A with Jorgos and Olavi now, but I know we're having lunch break after this. So few things. During lunch break, go and check our, there's few art installations in the lobby area from our amazing speakers. They're really fun, go and test. And another thing was that if we don't give you answers straight away, but both of these guys are gonna stay around, and again, they are really nice guys, so don't be too scared to ask questions face to face. And also, Jorgos is going to have a little session in the evening in the sauna area, so you can join that. Sauna is not mandatory. So, but yeah, Juha, maybe if there's some more questions, please share. But one thing is that I was trending that a lot of people are saying that standing is just as bad as sitting. So, I mean, well, I guess you already answered the question. It's not as bad, but you know,
it's not that great either.
Yeah.
You know, it's not a solution. It's something better we can do, but it's not enough in any form.
Yeah. So, I mean, you said something like move around every 30 minutes, but I'm afraid I'm going to get fired if I'm at the office and every 30 minutes I go walk around.
One solution is walking meetings. I actually used to do that for our daily meeting, because that's a meeting where I don't need to say that much or like stand on my laptop. I can just walk around in the neighborhood and then say my part when it's my turn. I love that.
Yeah, I think that's going to be a cultural change that we need to force, because, I mean, just as an example, I was speaking to a friend who's in IT and he works in a bank, and we were having this conversation about sitting, and he said, we have this guy in the team and he's a little weird. He goes at every lunch at 1 o'clock, he goes out and walks for an hour and then comes back. And I said, so what is your issue with that? Like, I think that's commendable. Like, I should be copying that guy. And he said, well, you know, he kind of leaves us. And, you know, like, who's going to take care of the systems? And I'm like, well, you should be putting that in your plan. Because if he gets a really bad injury, like his back, you know, really gives out, and then he's gone for a month, what are you going to do then? Yeah. So, you know, our businesses, whether ours or we work for someone, depend on us, and we need to be healthy to be, you know, doing the things we do.
Yeah. Olavi, have you noticed any changes after you started lumberjacking? Can you see?
Yeah, and I've noticed, and I'm in a super lucky situation because then I can work really hard physically, so I'm quite tired after that day, but then the next day I will be working at the office, so it's like a really nice balance. But yeah, I've noticed that I don't think I would like to work 5 days a week on my computer anymore, because now I've got to used to this like working outside.
Yeah, we got it. You're entitled. You got to go to Australia. No. Is there anything that we can do to reverse the damage that we have already done? I mean, we're not everybody's 20 anymore, so.
Yeah, absolutely. I mean, look, not everything is reversible. So the dehydrated disc, there's some research that trying some things with stem cells and stuff and some surgery, but it's not there yet. Maybe we'll never get there. But this is not the point. I mean, a lot of the stuff is reversible, right? Even the gene stuff, the changes, but it requires work from us every day. So we need to get on a habit that, just stacks the activities, and we just start doing more and more and more and more. And we get into a lifestyle that is more similar to what the hunter-gatherers were doing, rather than just just typing all day. So yes, I mean, most of it is irreversible, unless you're 70 or 80, which you don't have enough time anyway. So the earlier you start, the better.
So I have two kinds of news. One is the food is ready. The second one, if you want to stay and get more responses to your questions, stay here. If you're hungry, go outside and watch the stream later. It's your choice. So if you're hungry, go out now and leave the rest of us here. So hungry people go. So you're hungry for information. So we stay here. And when you're really hungry, then you eat.
Yeah. Okay. Any tips for physical activity if you don't have time to go to gym or time to cut trees or something like that?
Yeah, look, obviously there are things you can do. I mean, you can get up and walk quickly around the house. That's something that adds to something. But you don't need to do hours and hours of exercise every day. Like if you spend half an hour, 45 minutes on yourself, that's going to pay a lot of dividends. And I'm not saying that I'm perfect and I do this every day. Obviously I have my demons as well, and sometimes I miss this, but I try, and we can all find that amount of time. No one is that busy, or if they are that busy, then I think there's things to discuss there. But yeah, I mean, even the World Health Organization has shifted in their guidelines now, and they're saying that every little activity counts. Everything you do counts. So just keep doing more things, like the walking meetings, just going outside, getting some air, doing a little bit of cardio. I don't know, doing some push-ups, whatever it is you like. Just try different stuff and see what you like. You're gonna like something. Most of us think we don't like exercise because we never tried it and it feels uncomfortable to just start, right? So, just open a YouTube video and try something. It will be uncomfortable, but you will feel great afterwards. And then, from that, you can go to a class, because then you'll meet some people too, and so on and so forth.
Olavi, do you do some exercise on top of your work?
Yeah, I play hockey, and then I now try to start jogging. So because I'm gonna run a half marathon, I have been running 5 times already, or 4 half marathons. So, yeah, I would say a good way is also to not use an elevator if you go to an office. So I did that. I made the decision that I will never use an elevator again at my previous customer at Sanomatalo, which is we had to walk 8 floors up. And then Corona happened, so then we didn't go to the office anymore. So I never used the elevator since. So yeah.
How about settled chairs or other tools at the office that
Yeah, look, ergonomics are great. I have a good chair. I have a Herman Miller chair. But the thing about the chairs is that they don't really, they're not going to improve your health markers. They just reduce the impact, right? So that's important to keep in mind. So reducing the impact is not the same as zero impact. It just means you will feel more comfortable for more time. And that might be a bad thing, because if you had a crappy chair, it might actually force you to stand up more and move around. Yeah. So it's something we have to regulate between ourselves. So if you're good with breaks and you set a timer or whatever and you move around, then get a good chair. But if it prevents you from getting up, I don't know if it's a good thing.
Yeah, I think that's one of the biggest differences, at least for me, when I go to the office versus working from home. Because at home, I might just sit still for too long time. But at the office, I would go to the coffee machine and walk around a bit and have a discussion there and chat and go for lunch, walk somewhere. So it's better, in that sense, it's better to go to the office.
Yeah, and in the ways that we can make excuses for ourselves to move, why are we automating the stuff that makes us more lazy? Why are we automating, the turning on the lights when we can actually get up and do it? Why don't we automate some things that makes us move? I don't know, like we have to chase a robot around the room or something.
Humans are lazy by default. We are saving energy for something. Thank you so much. Like I said, feel free to talk to them, ask more questions. I think we covered the main topics. And yeah, enjoy the lunch. See you in 1 hour.
Good job, man.
The deep vibration holds the scurrying and clicks. Merge with the humid drone. Let the jungle's unseen voices awaken your primal roots.
Hear ye, hear ye. Hello, everybody. Welcome back from lunch. I think we can all get settled in here in the next couple minutes. Did anyone check out the art installations while they were having lunch? Any art installations? Yeah? I thought that was some cool stuff. Always into the integration of music into kind of a tangible form. That's really cool. Awesome. Well, other things I'm into include design systems, which is a perfect segue into our next section today, where we're going to be covering future-proofing design systems as well as building design systems in quite a constrained format. I think we're going to be covering a couple really cool things here. So I first want to hand it off now to Julian Solpes, who's going to walk us through some design system work. So let's give him a round of applause.
Thank you. Hello, everyone. I hope you're doing well and you enjoy the conference. Today, I would like to share with you some insights about how to implement design systems, and more specifically, how to avoid that they become outdated the next time a new shiny JavaScript framework comes out, so every week or so. This will be based on my experience in building 2 large-scale design systems over the past few years. So what I'm going to present is obviously not the ultimate best way to implement a design system. It's just something that I think works in this kind of context. So let me give you first a bit more details about the kind of organization we will be dealing with. So it all starts with a design, our brand that we want to bring to life into digital products. For that, we have a few platforms at our disposal. I will be talking about the web, but we could have mobile apps too. On the web, we will likely use a JavaScript framework like React, for instance. And in our large organization, we will have like many projects using React. But in a big organization, it's very common to have more than one framework. So maybe some people will prefer to use Angular for their projects. So again, we will have many projects using Angular. And then people can use additional libraries for their styles. For instance, Tailwind CSS is quite popular today. And in fact, you could use Tailwind CSS alone to do a simpler project. So the big question is, how do we implement a design system in this kind of context? We could build like React components using some kind of primitive like Redux UI or headless UI, but they will be usable only in React projects. If we want our design system to be usable in Angular applications, we will have to basically build everything twice, so it doesn't seem optimal. Another issue is that if one day, maybe one of these frameworks become outdated, well, all the code you have for this framework will become outdated too. So in fact, it's the case of all what I've called tools, like JavaScript libraries and frameworks that we use to build our applications. We use those tools which are built on top of the web platform. But the web platform itself has evolved a lot over the years. A few years ago, we needed a lot of JavaScript code and maybe some libraries to build a modal dialog. Today, we have the dialog HTML element, which works probably better than any library. A few years ago, we needed CSS preprocessors like Loda, like Sass, because we didn't have nesting or even variables in CSS. Today, we have custom properties that we can type. We have, of course, nesting, and even CSS functions are on their way. So the web is evolving. And I think as the web evolves, the tools we use will either have to evolve to adapt to the new web features, or maybe some tools will just disappear because we don't need them anymore. So I think it might be a bit risky to base our design system onto those tools because we don't know what will happen to them. So what we are going to try to do is put as much work, as much code as possible in the platform layer, independent of any JavaScript framework or library. So let's see how we can do that. We will start with, well, the root of all design system, which is the design itself. Let's say we have a component, a simple component like that. What makes this component your component? What makes it different from the same component in another design system? Well, it's all the little choices that the designer made to assemble this component. For instance, the background color, the padding, the icon, and all the little details that make this component. So those are design tokens. Design tokens are a representation of a design choice that will be shared amongst all the teams and everyone that will use or implement this design. So it's the single source of truth for all design-related decisions. Here, it's in general, we will have design tokens are built in layers. So we have a whole hierarchy of design tokens. Now, the exact hierarchy will depend on your specific needs. So this is just an example. The idea is that it's part of the designer and developer's job to define this tokens hierarchy. And then the designer will find the values for each token to design the components. When the designer's job is done, when he or she has found all the values for the design tokens, we can start implementing the design using the design tokens. So we will step into the platform layer. So we have our collection of design tokens in our design software, maybe Figma or Penpot, maybe using Token Studio. What we want to do next is to generate some code, some variables in the code in syntax, depending on the platform we will be using. For the web, we can use CSS variables. On Android or iOS, we could generate files in those syntax. And here I said generate and not write the variables, because we can easily reach a few hundreds, even a few thousands of variables. So it will be a bit tedious to write by hand. What we want to do is try to automate this part, so generate the code from the design. There are tools like Style Dictionary, for instance, which can first generate some JSON files from the design software, and then using those JSON files, generate some variables in the code. So we can use some tools, or if you have some custom needs, you can still write custom scripts to generate the code from JSON files. It's not very complex to do. So then we have our first layer of our design system, a collection of design tokens implemented using CSS variables. So here, let's see how it can look like in a code base. I have here an example repository with a few packages and a few apps that we are going to cover later. For now, let's see what's in the tokens package. It's a very simple package where I use the Style Dictionary CLI. Is it big enough? Yes, I guess. We use the Style Dictionary CLI to generate the CSS files. So for the inputs, I have two JSON files. The first one contains all my colors. And next, I have some spacings. And then I have a components file where I have my components tokens. So I have two components, a button and an input with components tokens. And using those files and the Style Dictionary CLI, I can generate some CSS files. So I have my theme here with all the colors, the spacing, etc. And then I have a CSS file for each component. For the button, I have my button tokens that reference my core tokens. And then for the input, I have the input token. So all of that is automatically generated. Every time a designer updates its design in the software, we will generate those variables. So here we have a solid foundation to start implementing the component styles in our design system. Now, here what we could want to do is import those tokens, those CSS variables, into our frameworks components, so like React or Angular or Vue. But here, as soon as we are using frameworks, we are already in the tools layer, and we don't want that, or at least we want to delay that part as much as possible. What we can do instead is implement the component styles in plain CSS using either HTML tags or CSS classes to stay in the platform. So what it looks like in my packages, I have a CSS package which will import the CSS, the tokens package. That was a dependency here. And I will just implement my component styles in Sass here. So I'm using Sass, but it's a preprocessor. So the output of the package is plain CSS. Maybe in the future, I will remove Sass because I don't need it. So I'm using a library, but it's a dev dependency. It's not a hard dependency. So I have implemented the component styles using the design tokens that were generated before. So I import my design tokens and I just implement my component style. I am always using a prefix here because if it's plain CSS, there's no scoping. So whenever I will import that, I want to have at least a prefix in the class name. And so yes, I have in the output, I will have some CSS files for the styles of my components and a bunch of global shared styles. Okay, and here at this point, we can already see the components in a plain HTML file. I just have to import my global styles and the component styles, and I can use plain HTML to see what my component look like. So I should have a little server if I start it. Okay, not this one. So this is the simple, very simple sample page that I use to showcase my components. So it's plain HTML, CSS. In a real-world scenario, we would use something like Storybook to display, document our whole component library. Here it's a very simple example. So we can already use the components using plain CSS to do a very simple HTML forms, because HTML forms work great. Okay, but of course, those are very simple components. We don't need JavaScript yet, but for more simple components like a drop-down menu, a sidebar maybe, we will need some JavaScript to have some logic, some behavior. And here again, what we could want to do is import the component styles, plain CSS, into our JavaScript, our frameworks components in React. But again, we would be using the tools. So ideally, we want to have our components logic, our behavior in plain JavaScript, or at least using standard APIs. But now we don't want to write a bunch of HTML code for each component, import a CSS file, a JavaScript files. It's a bit like a Bootstrap style more than 10 years ago. Today, we are more used to components. We build web pages using components. So we would like to provide like standalone components to our users. And we can do that using standard web APIs using web components. Web components allow to do exactly that, to provide a set of encapsulated components with their own template, style, and behavior that we can use in any web page. Now, I won't go too much into details of web components because it's quite a complex topic, and maybe you already know it. So I'm just going to mention the few APIs that make the web components. First, there is a custom elements API, which allows to define custom HTML elements with their template, style, and behavior in JavaScript class. Then the Shadow DOM API will encapsulate those template and style into a separate DOM tree, so isolated from the main document DOM tree. And then a few HTML elements, like the template element, allows to reuse some markup, and the slot element will allow users to insert a piece of HTML into the elements. So web components will allow us to have a collection of custom elements that users can use in any web page. Now, writing web components involves quite a bit of boilerplate code, so we will want to use a library to help us write web components. There are, I think, two big players in the field. I know Stencil and Lit. So Stencil is the library behind the Ionic framework. It has a comprehensive tooling for testing and bundling the web components. And I would say that it has a great frameworks integration that we will see later. And the Lit library is a product by Google. It's a bit more popular than Stencil. It's used by large brands. it has a its API is a bit closer to native JavaScript features. Stencil uses JSX. Lit uses string interpolations. It's very it's closer to JavaScript. And I would say that the tooling is a bit less comprehensive than Stencil, and the framework's integration is a bit less good than Stencil. But it's up to you to choose which one you want to use. So I can show you an example of using Stencil. It's what I chose. So in my packages, I have a web component package that will import my CSS package, my component styles. I import the tokens package because it's where I have the theme of my design system. And then using Stencil syntax, I can write my web components. So again, I won't go into much detail, but you can see that I can just simply write my component, the properties, write some documentation. I render some template, and I could have some logic inside of the component. Here, I just don't need it. Okay, and here again, we could see our component using a plain HTML file, like we did before using CSS. Now I still import my global CSS files, my theme, and I import a JavaScript file that will define the custom element. And below, I can just use the custom elements into my form. So if I manage to start my little server, we should have the same thing, but built using web components. So again, we are still here in the platform layer. So we are using standard web technologies, and I still have my simple form that hopefully works like before. And again, here we would use something like Storybook to document all our custom elements, our web components, for a more comprehensive documentation. So at this point, we already have a collection of web components that we can use in our applications. But to build our application, we will still need JavaScript frameworks like React, Angular, or Vue. We still need those to build more complex stuff. So we are finally at this point where we will use the web components into our applications. Now, we can use the web component into React, Angular, or Vue components. It works. There is a little website called Custom Elements Everywhere that tracks how well the framework handles the custom elements. There are some differences between attributes and properties, for instance. All major JavaScript frameworks can handle custom elements. It works, but the developer experience might not be that great because in Vue, for instance, and Angular, there is two web data binding using vModel in Vue and gModel in Angular. And it works because the frameworks know the native input element. They know what event to listen to. They know what property to read. So it works like that. But with our custom input, they can't know what event to listen to, what property to read. So we can't use just vModel and gModel using with our web components. But we don't want our users to rewrite the vModel and gModel. The developer experience would suffer. So what we are going to do is what's called components wrappers, which are basically just components written in the syntax of each framework we want to support. And they will just forward the properties to the web component. So it's a bit more complicated than that. It's just an example to see how it works. But in general, we will have to configure the vModel and gModel for Vue and Angular, and we have to take care of the differences between attributes, properties, that kind of stuff. The good news is that the libraries we use, Stencil and Lit, can generate those components wrappers. Stencil can generate wrappers for Angular, Vue, React, and Ember, I believe. And Lit can only generate wrappers for React. So that might be something to consider when choosing between the two. And we can see here that it doesn't look optimal because we are rewriting some components that will just forward properties. So here we can already see that web components are clearly a trade-off here, a compromise that we make. They allow us to build each component only once and use them in all JavaScript frameworks, but at the cost of additional complexity, additional code. So it's clearly a trade-off. Here I did that in I use Stencil, so Stencil can generate React components. Here, when building the web components package using Stencil, it will generate some React components. So I have this file which is automatically generated and which contains my two components, my DS button and my DS input. So those are, they doesn't look like it, but those are real React components. So I can use them in my React project. I have my little Vite React application, which will import, well, my React package, my collection of React components. It will import my CSS files for the global styles and the tokens, because the theme is in the tokens. And then in any React component, I can just import the React components from the design system. Now let's see if I can type with one hand. I should be able to import my DS button. So I have auto-completion, auto-import. Non, c'est bon, merci. Thank you. I have the completion, auto-import. It kind of works like a native React component. And in fact, I even have all the documentation for my properties, the documentation that I wrote in the Stencil, in the web components themselves. So the developer experience is similar to when using a conventional React component library. I say similar because sometimes we get little reminders that those are still web components. For instance, don't expect to be able to pass JSX into the properties because web components can't handle that. So we have to use weird syntax because it's at the end, it's still web components. So again, we see the trade-off here because we are using web components, but I think it's not too bad, and it's a trade-off we can make in certain kinds of contexts. So again, if I can launch my little server, I should have the same application as before, but using React. Okay. So this is what we will finally provide to our users. This is the final architecture of the design system. We have all our wrappers built, generated for each framework we want to support, and that the users will be able to use. We talked about developer experience. I think, well, we saw that people seem to like Tailwind CSS. What we can do is allow them to use Tailwind CSS. But the important part is that we will configure Tailwind CSS to use our design tokens. We don't want people to have their own colors somewhere. We want everyone to consume the design tokens because it's the single source of truth. So this is, I have an example in my repository. I have a Tailwind CSS package, which is maybe the simplest package. It's just a Tailwind CSS preset, which is a JavaScript object, which contains all my colors, my spacings, and in fact everything I allow the users to do using Tailwind. So they will be able to use Tailwind as they use it every day. So for instance, I have in my React application, I have installed Tailwind. I use my DS Tailwind preset, and then in my React components, I can use Tailwind like I would. But the important difference is that here we can see that the Tailwind classes, the classes generated by Tailwind, will use my design tokens. So again, the developer experience is very similar. They can just use Tailwind, but Tailwind will use my design tokens. It's just like a convenient way to consume the design tokens. So this is a big difference between that and, I don't know, a design system based on Tailwind that we can find somewhere, because here Tailwind is just a detail. We could switch and use another atomic CSS engine like Uno CSS, for instance. We just have to configure Uno CSS to use our design tokens. So we don't have any hard dependencies to Tailwind. In the tooling space, I will just mention another tool. So this is just an idea. I didn't implement it, but what we could have in our CSS, well, we could have a rule that forbid to hard code some values, some spacing. There's nothing new here. But if we're able to generate the design tokens like before, we are able to generate a list of available design tokens with their values. And what we could do, I imagine, is an autofix rule that will replace the hard-coded values with the relevant token. I think it could work. And this is something I would love to use. Just write a gap of 8 pixels, you save your file, and you have your relevant token applied. So this is maybe my ultimate goal when building a design system or any other tool. I don't want people to use the design system because they have to, because it's a company-wide requirement. I want them to use it because they want to, because it makes their job easier and faster. And I think by having this kind of architecture where people can choose what tool they will use, I think that it improves the developer experience. So if I present all of that in another way, it looks like that. Now, maybe it reminds you of the clean architecture diagram. The idea is the same. We don't want dependencies from the inner circles to the outer circle. The inner circles are the web platform, native standard web APIs, and the outer circle is a set of tools that we allow people to use. But we could swap the external tools. We could maybe one will disappear. We don't know. But the idea is the dependencies between the different parts. So now let's see how we could use this kind of architecture in different kinds of applications. So for instance, let's start with a simple form, like we saw before, a simple HTML form. Well, for that, we don't need a JavaScript framework. Maybe we will just use the web components. We can put everything in a single HTML file because we don't need more. We can just import a bunch of CSS and JavaScript files, use the custom elements, and it works great. Maybe we don't need any build step. But of course, it's a very simple use case, but this architecture allows us to have a simple setup. We don't have to set up a very complex machine. We can just have a single HTML file. Now for a more complex use case, and I think this one is like the main use case of this kind of architecture. If we have private web app, like we could have dozens or maybe hundreds in a large application, a private web app with complex forms, this kind of stuff. In this case, we don't need the best performance. We don't need SEO. So I think a single page application would be good enough, let's say. In this case, we could import the web components, use the web components with the frameworks wrappers that we generated, because it works. It just works. We could use Vue or Angular or whatever, and of course we have the tooling for the developer experience. So yes, I think it's the main kind of application that we want to use with this architecture. Next example, let's say we have a public website, maybe with mostly static content, like a landing page marketing website. In that case, we need the good performance, we need the SEO. So maybe we want to go with, what's that? I don't know. We want to go with static site generation using Astro, for instance. I don't know what's happening. Oh, okay. I don't need internet connection. I will try to, speak as I fix the issue. Okay, I was thinking I was ahead of time, so that's perfect. That was planned. Okay, should I use something else? Alt open? Nope. I was so close to the end. Okay, I think there are maybe 3 slides left. No, Alt Open doesn't work. Well, I had to have some issues. The whole internet, you mean? Alto Open should work, or? Okay, it's moving. Perfect. What was I saying? Okay, let's go full screen. So yes, we have a public website. We want to go with static site generation because we would have the best performance for a static website. Maybe using Astro because Astro is great. In that case, I think web components might get in the way of features like server-side generation or static site generation, because while it's technically possible to render the components on the server side using declarative shadow DOM, I don't know if it's easy to use that in a JavaScript framework like Astro or Next. So if it's just a simple static page, it's probably simpler to just use CSS styles. But here again, you have the choice. You can use the web component if you want, or you can use just the CSS styles. And of course, we have the tooling for developer experience with Tailwind CSS or StyleLint or any other tool you can provide. Okay, and final example, let's say you have a legacy web application somewhere in your organization built with an old CSS library or an old design system. Maybe at least you can use the design tokens and configure your old CSS library to use those design tokens, so override the theme somehow. So at least share this single source of truth for the design so that you have shared colors and spacings, etc. So you can see that in all cases, we can pick exactly what we want, what's best for us using this kind of architecture. Now, the takeaway here, I think it's not the exact architecture because every need will be different. For instance, if you have a one big React project, or if your whole company uses React, well, I think it doesn't make sense to build web components. Just use React. But the thing is, think about the dependencies between the different parts of your design system. What parts are made of standard web APIs? What parts rely on external libraries and frameworks? And try to see how you can optimize all of this, maybe find compromise, so that if one day, we don't know, if one day one of these tools becomes outdated, you can just say, well, no problem, that was just a detail. So that's it. I have gathered a few useful links on this page, including the link of the repository I showed you. So if you want to quickly scan the code before we move on to the next talk. Thank you.
Round of applause. Great job. I think this is a beautiful approach. I also vouch for the use of StyleLint. Love that as well, yes. So we're going to go from having kind of an ideal world scenario of creating a design system, perhaps maybe from a greenfield project. And I believe as we introduce Mads to the stage here, we're going to be looking at a design system from a less ideal approach, maybe a less greenfield type approach. So we're going to see kind of maybe best picture and then some struggles that we might hit in the real world. So staying in the realm of design systems, but maybe in a less favorable light at this point. So at that point, everyone give a round of applause for Mads.
Okay. Thanks for having me, everyone. I'm really happy to be there again. With this talk, we're going to talk about design systems again, and we're going to talk about legacy stacks again, but as we said, in a less optimal context. So In this story, we will talk about bringing a almost 20 years old legacy web stack to something more modern and more organized than before, but without sacrificing a lot of different things. So it's a story about the future. And what the future? Because it's future front-end, and because we are bringing a web stack back to the future into a modern stack and modern architecture. But also because it's a way to me to be back again, because I was there for the React Finland twice, so I'm really, really happy to be back again. And thanks to all of you to having me on stage today. So what is that? All my stories start with that, which is a kind of dashboard panel. This dashboard panel was made for a company named Always Data. It's a PaaS provider I was working for. And with this PaaS, we had some kind of administration interface, something like that, where people could configure their website, containers, solution, providing workers and so on, blah, 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 you name it. So it's a very old stack, and our plan was to move this one from something very old to something, I guess, brand new. So I'm mad. I'm working in the web for more than 20 years right now, so I'm a bit old right now. And I saw a bunch of things that you don't want to see, I guess so, but yeah, we need to work with that. So this is exactly my story about bringing this old web stack to a modern front-end. So what are the origins about that? So as I said, it was an old, very old web app. It really was time to modernize the stack and to modernize what we had at this time. The fact is, the team working at Always Data is really a team of engineers, and almost just like that. It's a small team and a small company, but every people are engineers, and none of them were front-end developers. So they were doing front-end because it wasn't that complicated to build a dashboard of different widgets, but they are not really used to develop a real good front-end. So at some point, I was just asking for people handling the front-end in the team, because we weren't really able to push the things a bit forward, and we needed to just increase our productivity and the way we are delivering the product. So I asked for a front-end developer, and after a bit of negotiation, I finally had one. And the first thing that we had to deal with him was, okay, what do we have now and where we want to go? Because we didn't have anything, not even a UI kit. We had nothing to build our web pages and just working with a bunch of different tools. It was a Django application, so a Python application in the Django ecosystem, so a multi-application solution based on Django with a lot of different applications, because in the same Django core, we're running the dashboard that we saw, but also the website and also the different applications to manage databases and the webmail and so on. So everything was a different application into a single core application made with Django. So it was a multi-app context. We just used some bootstrap thing. So it was bootstrap with a bit of jQuery, and that's all. It was an 18-year-old code base. And we've got a few APIs for luck. Some publics for our clients, some private for internal use, but we didn't have API for every part of the platform. Just a few of them, which wasn't really easy. So how it worked exactly? It was something like that. You've got your agent is making a request to the Django framework, and the Django framework is generating some HTML. And while it was generating this HTML, it was also consuming some assets passed into a Django compressor. Django compressor was a plugin dedicated to Django to package everything like we had Rocket for Ruby on Rails in the past. So it was definitely not made for a modern front end. It was something really oddly opinionated, I said, something like that. So all those third parties were also injected into that. We were using Webpack behind Django compressor to package every part of the application to try to do something like more modern, and it was a bit spooky at some point. Okay, so we didn't work to work again with this stack. We need something more modern because we had the Django compressor, I said, we had Webpack, we had some kind of external assets, some bloated styles everywhere. Some inline scripts inside every kind of views that were generated with Django. We had some external scripts. We had some data inline into the views to be consumed by the script inline into the views too. And a bit of mess of internalization because some part of the application were translated using Django and passed as a JavaScript variables into the rest of the application. So we had to deal with that and to modernize everything in this context. So it was a bit complicated at first. What we were sure is that we want a component-oriented design. So something that we were able to modernize in a way we could handle an atomic design and put some atomic design concept into the development of our web pages. Because we wanted to be the pages or the views being composable, like I'm taking different kind of elements and I'm just aggregating them to build some views. So the engineers could be focused on just building stuff and layout inside their views and not dealing with the whole rendering of the different parts of the application. We want something nicely crafted to be able to push this architecture a bit further and to maintain it in the future. So something like a clean architecture that we mentioned previously, something like that. We want something like a solid design where we can substitute different parts when we need it. So it was really more well architectured than what we had before, coupled with a living documentation. So the different engineers could be able to understand how to use the different components and how they can be embedded in different parts of the apps and so on. And a distributed core assets. So everything should be packaged at some point and ready to be consumed. That was the idea. So finally, it's a library and component and a system built for the platform by the people doing the platform inside. We wouldn't probably not rely on an external set of components, library of components, something like that. We wanted to provide a set of templates, like layouts or something like that, to be able to build the pages, build the views, and so on, and for sure, simplify DevX. So we needed something that worked out of the box, even when you bootstrap new views for new parts of the application, new services that we will host in the past, and something like that. We want something battery included, but with no need to supercharge it, because days after days after days after years, we finally had some bloated script or bloated styles that were just contributed by the engineers saying, okay, this table don't look good in my new view. I don't know why, so I'm just gonna fix it in another part of the CSS file. And it's just another edition over another edition. And we don't want that to be done again in the new system. And something that where engineers don't have to deal with the delivery, and they should probably just have to put everything together, and the delivery of the front-end assets would not be handled by the engineers at the end. So something definitely out of the hand, just to simplify the developer experience. So let's frame it. It's just a design system that we wanted to build at some point. And we were totally okay with that. The thing was that we won't get rid of different things. We will stick with Django for obvious reasons, as the stack was 18 years old, and we wouldn't change that at some point. It was a team of Pythonists really used to Django, so we won't change their bit on this point. We wouldn't want to migrate the full platform to an API first platform or architecture, because we didn't have the time to do that, and it will make no sense at some point. So having a new web application entirely powered with React or Vue or whatever you want, and really to consume some APIs to manipulate the platform and the data in the platform was totally out of scope. We didn't want to do so. And we wanted to remove the Django compressor hell because it was just maintainable anymore. So we wanted to go back to something simpler and easier to use. So what was the tech foundation of that? We should have chosen the way of web components. I suggested it. But at that point, the engineers just say, okay, we won't go with web components for a simple reason. It's probably too complicated for us. It's web-based, and we are not front-end web developers. We are more a team of CSOPs and back-end Python engineers. So we want something that we can understand when we access the source of the design system. So we want to stick with something that we can understand, and web components logic are a bit way too far from our comfortable zone. So we get rid of the web component solution, and we were step back to the Django solution. So the first challenger is Jinja-X. Django has different kind of template engines. Jinja is one of them, and Jinja-X is an extension of Jinja that allows you to build some kind of X component like GSX or TSX components, but directly with a Jinja syntax. So it allows you to define your different kind of components that are ready to consume, like HTML tags. The great way is that you can define some props, and you can consume those props directly into your markup, like you did with just Jinja and some variables. So it's not that far from their previous habits as a backend developer, let's say, services developer. I prefer this term. And the good thing is that it can embed related assets. Like, okay, for this component, I need those CSS files and those JS files, and you have to serve them right now. And Jinja-X is intelligent enough to just gather everything and gives you a list of the different assets that you need to embed in your final view to have it running. So I can generate a page with a lot of components in it, and all those components will tell me which kind of assets that I need to include, and same thing for the CSS file, for the JS files. So it's a trade-off that we can work with. Second challenger is a JavaScript solution to be able to run the component, because right now we are just serving plain HTML to the browser. So we need to manipulate and to, kind of iterate with logic those components, like web components could do. And we did so using Stimulus framework, because we tested a lot of different things, and Stimulus was probably the best balance between the complicated part of handling a new framework with a lot of batteries included and so on, like React and so on. And they could handle the existing markup by just hooking on the existing markup and powering it with some kind of logics. It's a way to declare it that is quite close to web components. So it's also a solution to push progressively the services developer to a more web component-oriented approach. But in the meantime, it's a good solution to consider. And we still had the problem of CSS and how to use CSS and how to exploit CSS in a way that we won't create some side effects when we load different parts of the components at some point and so on. So we choose to stick with Cube CSS, which is an approach like BEM, but really where BEM is fighting against the CSS concept. The Cube CSS is just embracing the concept of cascading and inheritance that is built into the CSS concept in the end. So it was our choices. Jinja-X, Stimulus, Cube CSS, and we were able to produce some kind of components ready to be generated by Django in its template views, but ready to be powered and to be rendered directly into the browser without any kind of pain, I guess so. We needed a supporting team for that, so we choose to work with Figma to just work with the design, because it's an industry standard, just to collect the legacy, because starting with an existing code base was really difficult, and you can't start a design system from scratch because it will be too complex. So we need to grab the existing content, inject it in Figma, and then work with the existing stuff to just, making a catalog, a library of the existing components and starting to build the interface and to restart new interface. We used a plugin for Figma called HTML2 Design, which is really efficient for this kind of work. So we were able to refine the components in Figma, create and managing the design tokens directly into Figma, and then export them to be ready to be used in the Cube CSS-oriented file. We choose to finally use Vite rather than Webpack for obvious reason. It's the way to go right now if you want to package different kind of assets. With Storybook because it's an industry standard, and to define workflows to the different part of the team. So the engineers could be ready to contribute to the design system, and we were ready to handle those requests, but they can't have the authorization, let's say like that. They weren't allowed to directly supercharge the different parts of the components that they were working with. It worked well because it was a small team, and we were really able to deal with it quickly when we had a new request coming from them. But we still had some unknown parts, like how to deal with configurations. We don't know at this point. How to work with a properly architectured component, so how to distribute them and how to give the users the way to build the different views. How to make Vite and Django work together. We didn't know. How to use components outside of Django, because if we wanted to display those components into Storybook, how to use Jinjax in Storybook. We didn't know at that point. And how to package everything from production, because it's a nice idea, but how to put it in production finally. And finally, the idea was we didn't want it to be a big bang, like replacing everything and running, but something really progressive in the evolution. Not to lose our final users in the overall experience, and just to be sure that everything were working at first. So the idea was to replace the existing build stack, Django compressor and Webpack and generated views and blah, 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 with the new one without any change visually, just to be sure that everything is working. And after that, we will be ready to make some baby steps to implement the changes into the design and moving progressively into a whole design system-oriented solution. So how we did that? We had to start it somewhere. So we created a new app, a new package into the Django core, named UI, and this package will be responsible to handle everything dedicated to the design system and the UI stuff. It was responsible to host different things like configurations. Everything was in the UI package, different kind of helpers, just to help to import some things and so on. The different plugins, different kind of templates ready to be consumed by the final users, and the components themselves, obviously, and the assets related to that. And we wanted it with no dependencies to any kind of other packages in the core Django. So the apps in Django will be dependent on the UI package, but the UI package will be totally standalone and totally able to work outside of Django if we needed it, and we will need it for Storybook. So we created a sandbox with a simple demo app, and we started to work with that at some point. The first thing was gluing the parts together. So the first idea was we've got one app. Each app was one workspace in the PNPM sense and one package in the Django ecosystem. One app, one PNPM workspace, one package. And everything is properly, arranged in the code base. We created a lot of different Vite custom plugins dedicated to a small part. The first one was to reading Django config directly from Vite. Because if you want to start with having a design system powered by Vite to package a web application, but Django need also to know where to contact Vite at some point when you are running in the development mode, or when you are dealing with where to put the different assets generated and so on. You can have different source of truth for the configuration too. So because the application was developed by the service developers that were used to Django, we stick to the Django configuration. We generated a JSON file from the Django configuration ready to be consumed by Vite. And then in the Vite config, we just extracted the content. So one source of truth for the configuration, it was in Django, and everything was read directly by the Vite config when needed. We were ejecting all the images as references because when you are developing a full GS application, you can import your assets and import your images, but we won't do that because images are just, written in the HTML generated by Django. So we needed those images to be grabbed by Vite and packaged by Vite. So Vite needed to be aware of the existing images. So we forced Vite to consume all the images in the code base and injected them in Vite with a dedicated plugin. We produced an SVG sprite for the icons, and we generated a manifest.dev.json. Why? Because Vite is able to work with backend solutions like Django or like Laravel in PHP or Ruby or whatever you want. But to do so, the backend frameworks need to be aware of what Vite has generated during its process. So they use the manifest JSON file produced, which is just a mapping between you ask for the index.js file, this is the generated file that is containing your JS index file and that you need to embed in your final application. Okay, so it works well in production mode, but you also needed that in development solution just to be able to, to map the right thing at the right place. So we built a little plugin to do so. Then we created a Vite-based config, which was a common config for all the application, embedding all the Django concepts that we need to address, like where to put the static web files at the end and so on. So we did so, and every application in Django will have its own Vite config consuming this base configuration. And we made a custom tag in Django to just include the Vite.js file, which was something like, okay, we will use Vite and we will need those JS assets in this specific view. So let's do your magic, find in the manifest the right file that were generated for those asks at this point and inject them in the final views. So it's a bit of magic, and we had a bit of magic over it, like caching the generation of the configuration, reading directly from the Django templates to be able to automatically set the import endpoints into the Vite config, auto-importing different kind of components. The idea is that we just wanted to enhance the developer experience at the end. And because they were Pythonists, we stuck to the Python ecosystem. So we use Poetry, which is a standard to contain the environment for the developers. We used Poet, which was a task runner dedicated to Python to wrap the GS task. And we were using PNPM called by Poet to run the different parts, which means that for the backend developers, it was just like, okay, run dev mode for this application, and everything was launched. The Django framework, the Vite development mode, and every asset will be mapped together, like the Django application know where to call the backend framework, the backend solution powered by Vite for the static assets and so on. So we have some kind of shell ready to run the overall application. So now we have to migrate the code base inside it. So what we did was something where we don't want to break the system. So we started by moving the base legacy templates into the UI package to be able to have it available everywhere to be extended in the Jinja templates. We were replacing Django compressor and get rid of it and move to Vite. So we had something that worked. And then for each application in the core, we had to create a Vite config file ready to consume the base command part. We were extracting scripts, all inline scripts in dedicated files, and we kept the data in data blocks into the views when we want to consume this data coming from the backend into the front-end components, into the front-end views. And we created a cheap feature flag system like, okay, we are in a view, in this view, we will have charts, and because this kind of view could be used with or without chart, or with a legacy version and a modern version, we just, in the Django template, enable a flag, and we can read this flag directly into our JS files to load dynamically the different modules responsible for, okay, I want to load this specific part, this specific component, and so on. It's working not that bad, I guess so. About the delivery, we let Vite build everything, so packed everything for the application for each workspace. So each app were responsible of its own final assets. We packaged everything using a building Django function, which named collect static, which is just collecting, as the name said, every static in your Django core into a single endpoint. We packaged everything and pushed it in production in a version CDN, which means that prior any upgrade in production of the platform of the solution, we were building the related assets, saving them in a new version, pushing them in production in a new behind a new server version number, and we were able, when moving in production, to call the new asset, request the new asset, and everything is working well. And just in case everything went bad for some kind of solution, it was easy to roll back because the previous version of the static asset was still available. With some kind of magic again behind that, but I can talk about that later if you want. So one step at a time, we moved all existing code base to Vite. It was working pretty well. We put on the magic to make it compatible with the existing stack architecture using Django. We went well with the UI package, which were ready to handle the different new components and so on. And we built a simple component ready to be integrated just to demonstrate the way we will use new components in Jinjax into our final application. So not a big bang, just a continuous progressive enhancement in our final application. It was great. It was working good, but it is not a design system. It is a collection of components, because the design system is also about communicating with the rest of your teams and the design and so on. So you need documentation. So how to document that? As I mentioned before, we choose to stick to Storybook, which is the industry standard at some point, at least at that moment, when you want to document your different kind of components. But how to use our Jinjax produced components directly into Storybook? Some of you may know that, but Storybook came with a server mode that is available. So it means that in your configuration of Storybook, you can specify a server endpoint, asking it as a base URL to call your components. And then when you define your stories, you define an ID, which is finally the endpoint that you can call on the server to get the component, and a different set of props that you want to define. And that will be translated into a single URL that will be called on your server part to get the rendered component that will be displayed into your Storybook. And you could dynamically change everything into your Storybook interface, like with any kind of React or Vue component or whatever you want. So for this rendering part, we made a simple Flask application, which is also Python, which is ready to handle the GJX template. So it was just a single API, ready to render the components and to pass the rendering elements to the Storybook, which is something we call component as a service, which is really, really helpful when you want to distribute your components dynamically. We could do that also with web components if you want. We could do that with a lot of things. And it's pretty well. We discussed about it in the workshop yesterday. But because the page that is served is just HTML with references to static assets like JS file and CSS file ready to power your components, we need to make a simple middleware to be ready to inject the dependencies needed by the component to be properly displayed, like the CSS file associated to that, and some kind of wrapper around stimulus to bootstrap the stimulus application, so the components will be ready to auto-register into the stimulus application in the end. So finally, it worked like a 2025 application, something more modern, like it's just building blocks in a legacy stack and a legacy application that won't have to evolve a lot in the future. All technologies were here, all technologies were ready. We just wrote a bunch of custom Vite plugins, but that's all. But they weren't ready to work together, and we had to use a lot of glue to make everything working well. But in the end, it was working not that bad, and we built an overall ecosystem around the design system in an existing legacy Django code base, a very old one, but ready to handle the new challenges of working in a new era of modern front-end with a design system directly into it. Thank you very much for your attention. You're welcome. And it's time for questions.
All good. Awesome. Thank you, Mads, for that. We have kind of a special Q&A session here because not only will we have Mads speaking towards their experience, we're going to bring Julian on the stage as well to speak about theirs. We're also going to welcome Jonas Kukkonen from Wunderdog to also speak about design systems and be a part of this Q&A. So I'd like to welcome Jonas and Julian back to the stage. We're going to sit. We're going to get comfy.
Yeah,
it's going to be a proper panel style, I think. Yeah.
You got some coffee?
No coffee. We have water, though. Isn't that close
nice.
enough? Okay. Yes. Thanks, everyone, for joining. So we have quite a few questions here. Thank you to everyone for being active inside of Clapper. I think we're pushing this thing to the limits already. So the highest rated question here would probably go to probably start with Julian here about web components. And it's often in our components, we deal with a lot of things like state management, business logic, and complex behavior. How can we really express these within our web components?
Okay, and if my mic works, okay. I think it might be a bit of a rabbit hole that leads to a kind of debate in the web community because there is like different use cases, I think, for web components and frameworks components. And when we deal with state management, business logic, I think it's more a use case for frameworks components, like React components, Vue components, or at least not in a design system. In a design system components, you don't want to put business logic at all. So it's more on the application side that we will want to have state management or complex business logic. And so in React, Angular, Vue components, it's technically possible in web components. In Stencil, for instance, there is a little state management API, so it's possible to use it in Stencil web components. But I don't think I would recommend that. At least in a design system, there should not be too much state to share between the components. But I think it's more than the application side.
Yeah, if I could also add to that yes,
absolutely.
Business logic is not something that you should put into your design system. So therefore, the requirements for web components are not that huge as compared to like the other components in your application. And then the way the state management is handled in web components is like that's the part where you bring in those third-party libraries to kind of like extend the capabilities of web components. And I do understand that kind of goes against the basic idea of like getting rid of the web components, getting rid of extra JavaScript libraries.
Anything that you would like to add about that, or do you think they got it pretty well covered there?
Good.
Pretty good? All right, cool. Staying on the topic of web components then, another question here we have is, you mentioned, Julian, in your talk about not being able to pass JSX into the web component because it's just a web component, beneath the hood. How would you go about then approaching composability and composite components within the world of web components?
Right. Composability would be used with slots in web components. So slot is like React children. So you can perfectly put components inside other components and use composability that way. You can also have named slots in web components. Like it's a bit more like view named slots. So you can have multiple slots in one component and insert them whenever you want in your template. So it's like we can do that in React using, for instance, the render property pattern. So we can insert multiple JSX nodes in your component. So it's also possible in web components using the slot and named slot APIs.
Anything from you, Jonas, on that? Or did you pretty much have it well covered?
Yeah, I think it's like well covered of like how to compose those web components. And I guess just to also, if the question is more about like, well, how do you compose design systems in general? Like what type of responsibilities do you give to those design systems? The business logic was mentioned earlier. That's not something design systems should handle. But then in addition to that, it really depends on the organization and your team of like how much other presentational responsibilities you give to your design system components. Some organizations want only design tokens. They might want to get rid of, like to have like no components, only design tokens. And then you might have some organizations and teams that really want a lot of components, a lot of different components. So it does vary organization to organization.
Yeah, I guess it's probably something of a governance problem. Like if we stick properly to an atomic design approach, finally you should not have to embed JSX and framework directly related logic inside a web component. They should be just outside, like just building the template or the big organisms or something like that. And inside that, it should be only web components finally.
Yeah. So shifting gears a little bit away from web components, I think there's a lot of interest, Mads, in kind of your path through this whole journey that you went through. I know I would have been intimidated stepping into a Django code base and being like, how to make this reasonable. So looking back at your path now, if you had to start it all over again, would you take the same approach? Would you change the approach? Would you just scratch it, go greenfield? How would you approach it now if you entered the same problem now?
That's a nice question. If it was just me, I would have go with just revamp of the way the backend is just serving the different services with an API first architecture. So we could have built a web app totally in the good way of it, like using a React or Vue or whatever to consume the APIs, and that's all. And which means that we could also have a mobile application or something like that. So it increased the different kind of possibilities. But the team really weren't ready for that because it was not the way the stack was designed in the past. So it was not doable, and it's still not doable today. Or it is, but it's a huge amount of work. And it's a nonsense. I would have preferred that we would stick with only web components because it's give or take what we made with the Shinja-X generated syntax that looks like components with some logic handled by custom scripts that are auto-registering to hook up onto the templates and so on. But I understand why the team just said, okay, we don't want to learn stencil or we don't want to learn lit or whatever. We prefer to stick with simple things that we understand, generating templates and putting some kind of magic JavaScript stuff on it, and that's all. And I totally understand that. So I probably won't do it differently today. I don't think so, because it worked well enough to have the team committed to use this design system, which is the final goal of it. So yeah, it was definitely the best trade-off that we had.
Yeah, and I really like your story as kind of like a story like how to adapt to the engineering team, because like design systems have two main value propositions. For end users, it is that consistency that you can have in your UI, and then for the engineers, it's a developer productivity tool. And it's not a productivity tool if you go there to the team and say like, well, now you have to learn all of these new technologies and this old code base, say goodbye to it. We're going to rebuild it.
Yeah, definitely.
It's a great point. Cool. So one other thing here that I think we can get into, there's a lot of talk about web components. I think we should make this as a note for next year. But there are challenges using web components in server-side rendering. Would any of y'all like to take the ball on speaking about how to maybe approach some of those challenges? Is it worth approaching those challenges of using web components in a server-side rendered environment?
Well, at the end, I took the easy path of saying, well, don't use web components for static site generation, because I think there are cases where they will just bring more problems than they will solve. I mean, it is still possible. Stencil, for instance, provides a function that you can call on the server, a function like render to string. So you can render your components on the server side. It works, but will it work? How will it handle like partial hydration on the client side? How do we handle that? I think it's way more complex when using web components. You can't expect to just use web components and everything will work. It's a big issue that the framework authors have to make web components work with advanced features like selective hydration and that kind of stuff. And I understand that they already have enough on their plate, and I understand that they don't want to work too much on web components because it's very difficult. So yeah, it's a trade-off.
Yeah, and Lit, the library that you mentioned, they are experimenting with the server-side rendering, trying to offer new tools. But even that, it's like, I don't know if they say it's like in preview mode or something, like they say like do not use it in big applications in productions yet. And some of our clients, like the server-side rendering, it's like a biggest obstacle for the web component adoption. Like a lot of teams are like scared of like SEO and other impacts, even if they don't need server-side rendering now, but they might think about like, well, what if we need it next year? Will we have to like rewrite everything?
Yeah, definitely something that comes up a lot in the world of design systems. I'm faced with the questions as well myself, so quite interesting to hear y'all's perspective and your experience with it. The last thing here that can be real quick. Did everyone have access to Julian's QR code to the repo, or does anyone still need that to be displayed?
You can just come after and
okay. If you still need it, sure. Come up. Julian will share that with you, so we can make sure to share that repo and you have access to that content. But with that, let's give one more round of applause to our speakers and our QA. Thank you. Thank you. Now with that, we will take a short break and we'll be back, I believe, at 3:30 with our next theme. See you then.
Welcome back, everyone. We are starting our final session of the day. This is a bit of a, well, not maybe a lighter topic, but we're going towards more creative part of the day. And our first speaker is Charlie, a creative technologist, and she's going to tell more about herself. Give it applause for Charlie.
Is it working? Yeah, cool. All right. Hello, everyone. Thanks for coming back after the break to watch my talk about motion control with multimodal AI. But before I get started on this, a little bit about me. I go by Charlie online usually. I'm a senior research engineer at CrowdStrike. That's a cybersecurity company. So what I'm going to talk about today, it is research, but it's personal research. It's not research in cybersecurity. But sometimes, you know, when you do research, you can kind of apply the same methodologies in like the way that you're thinking about the problem, that you're testing hypotheses and things like that. But outside of my job, I am an author. I wrote a book about TensorFlow.js back in 2020, so it's kind of old now, but it means that I've been doing things with motion control since about 2018, so it'd be like 7 years. And I'm also a front-end master's instructor. So if any of you is like using the front-end master's platform, I gave a talk about TensorFlow.js as well there. I mean, of course. And yes, as I was introduced, I'm basically a creative technologist. And otherwise, outside of tech, I'm trying to get better at having non-tech related hobbies. So recently, I got my diving license. I'm not very good at it, but you know, you get better by practicing. I am now a runner. I never thought I was going to be a runner, but now I run races, trying to play the drums, learning German, and I also, at the beginning of the year, I got my technician license in radio. So if you're part of the radio amateur community, it's usually old people, but anyway. So my call sign is KO6 HPR. If ever there's a zombie attack and you turn on the radio and you hear KO6 HPR, it's me. Anyway, okay, so let's talk about motion control. So as I said when I introduced myself, I've been doing this for a while. And at the beginning, I was using a platform that's called Teachable Machine. So it was a website built by a team at Google. And the point was to help people train or build a classification model very quickly. So you had an interface where you were turning on the webcam, and you could feed it certain images with labels, and you would train a machine learning model right in the browser, export it, and being able to then add it to your apps. So I think the very first thing that I built, I called it Teachable Keyboard, not very creatively, keyboard with Teachable Machine. And very quickly, so I fed it images of me tilting my head in different directions, and then I exported the model and built an interface where basically with my head, then I was triggering that, I mean, I was turning that into commands to write something on the screen. So it's like left, right, and when my head was down, it was basically entering the letter. But after playing with this, I wanted to kind of go a little bit further. So I started then using models or machine learning models that do more specific things. So for example, here it was a facial expression model. And I don't know if any of you remember, there was like a game from many years ago called Rainbow. It was an iOS app, and you were making funny faces. And if you do a shocked face, then the emoji goes up. And if you frown, then it goes down. And you're supposed to catch the stars and avoid other emojis. But I don't have an iPhone. I'm an Android person. So I was like, I want to play as well. So I built a web version of that so that anybody with a browser could then play a clone of Rainbow. So this model here, it wasn't even TensorFlow.js, it was another one. I think it was called like Face something. It was like a random JavaScript library. But I wanted to go a little bit further again. So I moved on to more, let's say, granular model, and I started with pose detection. So if some of you have watched Squid Game on Netflix, there's this game called like red light, green light, where when the doll turns its face, you're supposed to like freeze. And then when the head is like not looking at you, you're supposed to like run and try to survive, basically. But again, I thought it would be fun because it's like, well, if you can detect different key points in your body in the browser, then you can kind of make a little game at home. And when I talk about key points, what you get when you use either MoveNet or PoseNet from TensorFlow.js is something like this, roughly. So you don't get like the green lines, but you get the red dots. And you can have, I think, 17 key points. And it's basically raw data, raw X and Y coordinates of these key points on your body. And what starts to be quite interesting is that when you have just raw coordinates, how do you define what is like not moving, right? So if I'm like this, how do you calculate that I'm not moving versus moving? We're not going to do that right now, but it's kind of like the type of thinking that gets quite interesting. But then, okay, so then I moved on, and I was like, okay, actually, no. So in the demo with the Squid Game, I was using all the key points of the body, but you can also use the same model to build, to only focus on a couple of key points. So for this one, I focused on the right wrist and the left wrist. And again, I think I like to create clones of things that exist. So there was a repo on GitHub that was a clone of Beat Saber using a frame. If some of you have used it before, it's like a library to do 3D in the browser. But the goal of them was to be used with WebVR. So you would connect your VR joysticks to the web, and you would be able to run that in a VR headset. But I didn't want to buy a VR headset, and I didn't have one. So I was like, I have hands, like I can play Beat Saber with my hands. So I modified the repo that I found to remove the part that was supposed to connect to joysticks, to then instead use TensorFlow.js with PoseNet and focus on the coordinates of my wrist. And then you add collision detection and things like that, and you end up with a game that you can play with your hands. But then there's some models that then focus on the hands themselves. So multiple key points in the hand. Instead of having just one on the wrist, you have a lot of key points on the hand. And one thing that I built with this is I wanted to experiment with what would it look like to use the tools that we're using currently. So that's Figma. To build interfaces. So here in the GIF, it's just a zooming gesture, but I also experimented with having like a pinch gesture that would grab shapes and like move them around. And you get to kind of think, okay, if we were then controlling interfaces with gestures, what would that look like? And what you get when you experiment with a hand detection model specifically is that you get a lot more key points. It can be quite interesting if you're thinking, okay, when I'm thinking about a pinch gesture, again, if I only get raw coordinates of fingers, how do I define that this is a pinch? We're not going to talk about this, but this is a nice exercise. And I think the last model that I used is even more specific. It's around gaze detection. So it focuses only on a lot of different key points around the eye. And what I was building here, again, a keyboard, I don't know why. But if you only have two inputs, left and right, then how do you write something? So here the concept is like not only working on the detection with like the key points, but also how do you reinvent the keyboard interface to be able to write faster? So in the very first demo at the beginning, I was going like letter by letter to the left or right, but that ends up being very long if you're trying to go to the last letter. And here, the concept was to split the keyboard in two, and then if the letter that you want to select is in the left column, then you click left, and it kind of splits it into over time. So you end up being able to write a word pretty fast. And then I kind of moved on to be like, okay, so if you can write with your eyes, cool, but how could you code with your eyes as well? And you end up also, instead of just thinking about the detection, you also start to think about, again, if you only had left or right, how would you write code? I'm not saying like, should you, or is it possible? I'm like, how? And so you start thinking about when you write code, there's only a certain amount of things that you can do. There's a certain amount of ways that you can define a function, but you don't really necessarily do it with natural language until now, but we're not going to talk about that. So even if you write a prompt, like write me a function, it ends up being still code that is written in a certain way to be able to be run. So yeah, in this experiment, I still had a section with the different things that you could select, and then it was triggering snippets for React components in VS Code, and there was the live reloading. So then I was just writing a very, very small thing that was printing something on the screen. So at this point, it's like mostly models that were with TensorFlow.js, but I started to see some limits when I was working with this. So the custom detection logic needs to be implemented for each gesture. So if we're thinking about the hands, if you want to do a thumbs up and you only have raw data of X and Y coordinates, like how do you define that? How do you make sure that it's kind of like generic? So it would adapt. Let's say you were, let's say that you were defining a thumbs up with like, okay, all of the key points of the thumb have to be like, they have to do a line and they have to be 90 degrees. Like, okay, but then if I do that, you still know it's a thumbs up, but technically the angle is not 90 degrees. So when you're starting, this only for one gesture. So then if you want to have more gestures, you have to have specific custom logic for each. And if you're building an app that you want multiple people to use, it's kind of hard to be able to adapt to a lot of people. I'm not saying it's not possible, it's just more work. Detecting multi-steps gestures is difficult. So here, I'm only doing one, like a thumbs up or a peace sign or something. But if you ever wanted to build something where you would need a multi-step gesture, like sign language, for example, how would you, if you get 60 frames per second, so raw coordinates, how do you define, like, okay, one gesture first, the second one? Like, I haven't done it. I'm sure it's kind of possible. But again, I was like, it's probably too hard for it to be something that people would ever either want to build or use. Then sometimes it's too sensitive. So when I was experimenting with the pinch gesture on Figma to be able to grab a shape, again, if you're thinking at pinch, you'd be like, oh, maybe the tip of my index is like above my thumb, but sometimes, it was jittery a little bit, and even though I was almost, doing a pinch, it thought it was a pinch, and then it was like grabbing the shape, even though this is not what I wanted. So, sometimes it kind of maybe there's ways around this, but to me, it was kind of like a limit that I found working on this. And finally, the coordinates are relative to the window. So if you're building something and you're in front of your webcam and you're testing it at like this distance, for example, and you're saying, if my hand is in the top right corner, trigger that functionality. If my hand is in the bottom right, trigger another one. Let's say if you want to build an application that multiple people use and they tend to like maybe test the thing a bit further away from the screen, or maybe let's say like they're a child and when they put their hand up, it is technically the gesture that you want, but if their hand ends up being on the bottom right, then it will trigger the wrong functionality. So it's a little bit of an issue if things are, coordinates relative to the window. But this is what I kind of like stumbled upon when I was working with this. So I started wondering, can LLMs, or more like AI, multimodal AI, be used for motion control? So, now we're saying everybody should kind of like stay up to date with what's going on with AI, and I haven't necessarily been, a big fan of chatbots or something like that. So it's not the way that I get interested in keeping in touch with technology. So I was thinking, I love doing motion control stuff. Can I leverage what's already there, multimodal AI, for the same purpose? Can it maybe remove some of the limits that I've been having doing custom stuff? So the purpose of this research, I wanted to research how or if LLMs can be leveraged to create motion-controlled experiences. Okay, my goal was to control a website or IoT devices with hand movements using Gemini. The reason why I'm focusing on Gemini is honestly because it's free, and I haven't used it with other models, but because it's only personal research, I don't necessarily want to spend a lot of money. And also, if I don't spend money, it also means that people who have less than me, like students, for example, can also do these things. You don't need necessarily to have a team of researchers and super expensive hardware. So every time I do research, I kind of look around if there's existing research around this. And there are a few papers that I read, but they kind of focus on the idea of augmenting communication with, for example, future AI robots, like, for example, the humanoid robots, if we all kind of end up having this at home. When you think about communication, there's a lot of nonverbal communication. So, for example, even if I do this, I'm waving. I don't have to say I'm waving. But if you were talking to ChatGPT, but it wouldn't know if it's just text input or voice to text. Or even if I do this, it's kind of like a stop gesture. And I don't necessarily have to say something. And I think this research is more around this. So augmenting kind of communication systems for potentially human-robot interaction. So not entirely what I'm trying to do, but it's nice to know that other people are still experimenting with this. Okay, so just because I've been mentioning multimodal AI, in case you do not know, it's basically a machine learning system that can process multiple types of data, such as text, images, and sound. If you've been using ChatGPT, again, it's like mostly text or sometimes speech that becomes text, but now you can also feed it images or PDFs and sounds, and still have, that kind of like a nice output. Okay, so there are different approaches that I wanted to explore to be able to do this research. So first of all, I wanted to see, can I rely only on multimodal AI? So Gemini would take screenshots every second or multiple times per second, it doesn't matter, and returns its best guess for what hand gesture is executed. So my first approach would be like, no custom things. I'm just asking Gemini if it can recognize something in the screen, and from there, I will go. But then I was thinking, okay, can I rely on multimodal AI and augment it with fine-grained data from TensorFlow.js for maybe more complex interactions? And then finally, can I just like do my own thing and take screenshots from the webcam and convert it to vector embeddings and save it in my VectorDB, and then use Gemini only maybe for the text part of it, for talking to it, but maybe I don't want to send my screenshots to Gemini. So if you want maybe a more private solution and things like this, these are like the 3 approaches that I wanted to take. Before I do research, I always also have a few questions that I want to answer for myself. So here are a few. How many natural gestures can Gemini recognize? Can it accurately recognize custom gestures with little sample? Can it, or how could it, recognize multi-step gestures? Can it work in an Electron app? I think it's like most of the demos I'm going to show today are like browser-based, but because it's JavaScript, can you build like a desktop app, or even go further and try with like MCP servers and stuff? Can it trigger multiple functions successfully? Can the logic be triggered without text or voice input? And this one, I'm probably going to explain it now so that then the demos will make sense. Ultimately, what I want to do is to be able to make certain gestures in front of the camera and not even have to say anything and trigger the logic from Gemini. It kind of works, but it kind of also does not. So for the demos that I'm gonna show today, I'm just gonna have a trigger word, and it could be anything, but for some reason I always say like now. I don't know, as I show, I'm like now. So you're gonna hear me say now a lot. But yeah, the whole point in the end would be like I wouldn't have to say now. It would just be like checking regularly the images, and when it sees I'm doing a gesture, it would then trigger something. Then finally, it's like how accurate is it? And that's going to be interesting to see if the demos work or not. Okay, so first, let's just check the gesture detection. So, okay, maybe the code is a little bit small. I'm going to explain all the code that I'm going to go through. And obviously, this is like a small sample because the app is, all of my experiments is a mess and it's a lot. But first of all, I'm using the Gemini 2.0 Flash experimental model. I think it's kind of an old one now. Old, a few months old. I think that they released a new one that I haven't tried. So maybe it would be also interesting to see like if the demos don't work today, if I update the model, would it then work? Then usually you define response modalities. So if you want the model to reply to you in like voice, or if you only want to reply via text. So just for the purpose of this demo as well, I have audio so that people can, if you can't read, people can hear what the model is going to tell me. But the most important part is the system's instructions. So my very first prompt, kind of simple. I'm telling it, you are my helpful assistant, and looking only at the hand in the stream from the webcam, make your best guess about what the gesture means. Don't ask for additional information, just make your best judgment. Okay, demo 1. So here, let me see if I have to zoom in or not. What doesn't really, maybe I do. Wait. I should have probably also specified that I start from an open source repo that GitHub put together to show how to implement the multimodal live API. They just kind of made it easy, and then I'm adding my own logic. So what I'm going to need you to focus on is this column on the left here. So I'm going to explain to you before I do it, because once I start, the model is going to listen to me and it's going to reply, and we don't want that. So there's going to be a camera here in the middle. And I'm going to make a gesture. I'm going to say now. And here on the left, you're going to kind of see the logic that the model is taking. And you should see the name of the gesture that is kind of like trying to, or that it thinks I'm doing. So I'm going to put that back. Okay. Now. Okay. Now. Victory? Not yet. Wait. Okay. Now. Yeah. Okay. Cool. And if I do now, cannot classify. Why? Now. Victory. Yeah. Okay. Cool. So it kind of worked. So all right. So now we can see. Oh, thank you. Okay. So now we can see that there are, Now we can see that there are some gestures that it can recognize on its own. I didn't write any custom logic. I just told the model, hey, I'm giving you images. Tell me what you see. But it's not really interesting that way, right? What we want is to be able to call functions when I'm doing things. So that's called function calling. And what you have to do at first, you have to write some function declaration, which is basically a schema of how your function is going to work. And here I have a name. I'm going to say toggle light. That's going to be the name of my function. And I'm going to define that it receives a parameter. That's an object. And the properties, I'm going to have a property called on. And I'm saying it's a type Boolean. And the description of it is the light state as a Boolean. And I'm making it required. So every time that Gemini is going to toggle the light on, it should have an on property that is either true or false. And then that's like the rest of the function is pretty generic. It's an API. So these lights are called LifeX lights or LifeX. And here you can see that command.on, so it's going to be what I'm receiving. If on is true, then I'm sending a power on, otherwise off, and the brightness, whatever. And here is just the API endpoint that I'm sending the data to with the token. So this is more kind of classic frontend. But one important thing here is I have to update my system instruction, right? Because now I'm kind of adding a little step. So I'm still saying, make your best guess about what the gesture means, but then I say, and call the toggle light function provided. I do not tell it necessarily that to call it with on or true or false. I just say, call the toggle light function provided, and it's going to use the function declaration schema to then understand what it should do. And I'm passing the declaration in the tools section at the bottom. Okay, so let me just have a sip. Okay. This is where it's going to start to become a little bit more risky. So let me just, okay. So I'm going to do the same thing as I did. I'm going to turn the camera on. I'm going to do probably thumbs up, thumbs down. And let's see if it does what I want it to do. Now, now, all right. Woo. Okay. So what was interesting as well is that basically it looked at the gesture. It said thumbs up. Thumbs up is usually kind of positive. So then it decides that the value is true. When I do thumbs down, it's kind of, usually it's kind of negative, like, boo. So it understands that the value should be false. So this is kind of cool. I didn't really have to say you only have access to thumbs up, thumbs down, whatever. It just sees the gesture and then decides if it should be true or false. Okay. So, but what if I have multiple lights? At home, you don't only have one light, hopefully. But what do you do then if you have multiple lights? Because how do you know which light to turn on or off? So this is where we go to multi-turn function calling. Recently, I've seen it called compositional function calling. I don't know if they're exactly the same thing or if maybe I read it wrong. But it's basically being able to call multiple functions and let the model decide potentially which one to call first, or how it relates, how the two functions relate to each other, or what they return then relates to the second function. So to start, we have to update our function declaration, because now toggle light will need a light ID. Right? We have on, true or false, but now it's like, okay, which one, And here I am saying that the light ID is going to be a number, and the description, I don't really know if it matters, but yeah, the ID of the light to toggle that is returned by the getLight function. And I'm adding a new function declaration for a function called getLight. And here I have a property called detail that's going to be a string. And my description is the detail about the light, and usually a position. And the reason I did this is because usually we think, oh, well, you're going to give it an ID, like a number, a UID. But as a user, I don't remember the ID of my lights, right? So I'm not going to say, even if I was talking to the AI, I wouldn't say turn light like 43AFB, right? So at home, I have 2 Philips Hue lights. Obviously, I can't travel with them because you need like the bridge, so I bought these. And I have 2 lights under my TV, one on the right, one on the left. So what I want to be able to do is I could talk to the model and say, turn the right light on or turn the left light on, and then it will figure out which light to turn on, because I named these lights right light and left light. So there's, so that's why I usually said a position. If you were trying to trigger lights in different rooms, then you could do the same as well, like turn in the living room and it will figure it out. So we update the prompt again, and I say, okay, so this is where it's going to start to not work as much as I would like, but let's see. So I'm saying, look at which hand is making a gesture, right or left, call the function getLight provided with the correct hand position. So it should call getLight with the strings right or left, and then make your best guess about if the gesture means light on or off, and call toggle light. Okay. Okay, I'm going to go briefly to this. Again, if you can't read the code, it doesn't really matter. I'm sure you would be able to implement this. But using the open source repo that's on GitHub, they have like a use live API context to get the client, and the client is basically the multimodal AI API client. And there's an event listener on tool calls. So when Gemini is kind of like calling different functions, then it triggers our function here. And our two available functions right now are getLight and toggle light. It's just kind of a mapping. So we're going to start by looking at the function calls. So Gemini is going to return the functions that it thinks I'm going to have to run, or it's going to have to run. Here, I'm storing the response parts in an array because getLight is returning an ID that then it has to pass to the next function. So here we're looping through the function calls. It should be going getLight and then toggle light. So at first we're kind of destructuring and we are extracting the name of the function that it should call. We're kind of like calling it with the arguments. And then we're pushing the response from that call to the response parts, and then we're sending that back for another loop, right? So again, the response of the getLight should be an ID, and it will take that ID and send it to toggle light also with the on property that it should be sending. Okay. So I'm expecting this one to fail, but it's okay. And the reason is, and I think it's actually quite interesting to be looking at things that I thought were kind of like basic, but it's not really good at. So what I'm going to do is I'm going to point with my right hand, and I would like it to turn on the right light, and then the left light, but it seems to confuse right and left quite often. So let's see if it works. Now, so see?
My apologies.
Okay, maybe I'll try. It's getting confused, very confused. Okay, first of all, I think I pointed with my right hand, and the very first call, oh my God, it's making a lot of things up, said left. So I don't know if it's because the stream is like not mirrored or mirrored, but yeah, and here light ID 0, there is no light with ID 0. So I'm gonna try again, but yeah, this is where it's surprisingly weird that it can't recognize right from left. Now?
I apologize, but there seems to have been an error converting the light ID to the correct format. I will try again. Okay, I think I got it this time. I've turned the light on based on your right hand gesture.
Okay, so again, I think that I was pointing definitely with the other hand and it turned the right one instead. So this is one of the ways where, sometimes I think you really see when you play with multimodal AI how it can like hallucinate things, and sometimes when you get text back from ChatGPT, you might not see that it's not real. But when you play with this, you realize sometimes it does make up light IDs that don't exist, even though it's calling getLight. So it is looping through my lights and it's returning an ID, but then for some reason it's calling the other function with an ID that doesn't actually exist. So I'm just going to do something quickly. Turn the right light off.
Okay, I've turned on the right light.
All right, so this is not what I wanted, but you can see how sometimes it tells me it's turned it off, and it actually has not at all. So I'm going to do it myself. Okay, cool. I'm just trying to get back to like a proper state. Okay, and then I think after that, I wanted to show briefly in my questions originally that I was asking myself is like how, if I give it new gestures that it doesn't know, so not a thumbs up, not a thumbs down, and I tell it, okay, I think when I was trying earlier, when I was rehearsing, I think a pinch, it doesn't recognize what it is. So what I'm going to do is I'm going to say, okay, when I do a pinch, turn the light off, and then I'm going to try to turn it on, and I'm going to do the pinch again, and it should turn it off with giving it only one sample. So let's see. When I do this, turn the light off.
Okay, I've turned the light off.
Well, not yet, but now?
Okay, what can I help you with?
Now.
Okay, I've turned the light on.
Now. Okay, it did it, so I'm gonna like stop. Okay, so I turned the light on. The light on. My demos are actually getting worse, so I'm like, my stress level is Okay, so here it's like a difference between what I was telling before about TensorFlow.js, or even with Teachable Machine at the beginning, where you have to record a lot of samples and things like that. Here, obviously, if I refresh, it's gonna forget it, but you could see, if later on you can keep certain memory, or, later on, if you create your own, then you can possibly only do like one sample and it would kind of like remember it. So that's pretty cool. Okay, but now I want to move on to the more exciting, but also more likely to not work thing. So to mix Gemini with TensorFlow.js. So here, if we only rely on Gemini, we kind of have maybe like trigger gestures, like up or down. But what if you wanted maybe something that would require more of the different key points? So the idea for this particular section will be to point at a light, and it should turn the light on to start with. Then I have a trigger gesture that's like this to change the color. And then I'm using well, let me show you the code and then it makes sense. So when you start with importing, like for TensorFlow.js, you have to import the model and the TensorFlow.js core library. And here we're going to use the media pipe hands model. And you have to create what's called they call it a detector, but it's basically then you call detector.estimate hands. So it's going to try to find hands in the video feed. And you can then extract the different key points. So here I am extracting pinky finger tip and thumb tip, right? So I'm not I'm not showing you the rest of the logic because it's not necessarily AI related, but I have some calculation that looks at the angle between, let's say, like a horizontal line and an imaginary line between my thumb and my pinky. So that then when I rotate like this, I basically have like, 180, and I multiply by 2 and I change the hue of the light. So what should happen later, point at light, turn it on, trigger, set color, and then I do this and it changes the color. Okay, but what we have to do is update the prompt again. So we still have our look at the gesture, left or right, it gets the light, call the toggle light, but then if the user is making a palm gesture, call the set color function provided. Okay, I really want this one to work because it's like my favorite. But at least because it's JavaScript, if it doesn't work the first time, I just refresh and we try again. Okay, so I'm just going to open because I need to see. I'm going to see faster if it's not working from here. Okay. Now.
Okay, is there anything else I can help?
Now.
All right. Anything else?
Oh my God. Okay. Whee!
Is there anything else?
I didn't even have to try again. Oh my God. Okay. So it worked. But yeah, so it's like, okay, I experimented. Can I mix Gemini with TensorFlow.js? The answer is yes. And okay, then I'm probably out of time as well anyway. But the other idea would be like, can I DIY it with Vector DB? So I don't have a demo for that one. I mean, I did have a demo, but it's just not working. So I decided to cut it. But I'm going to talk about the way that I would have implemented it. So using data stacks, which is a Vector DB. Here, if I just zoom in, I had recorded before 3 different gestures. And you can see the only thing that is stored is vector embeddings. So what I had done is I had a web app that I was taking pictures from, and it was on the client converting an image to vector embeddings and only storing that in the database. So then let's say you get hacked, you can't really reconstruct an image from from vector embeddings. So even if someone had access to all of the images of you in your living room or something, they wouldn't be able to actually see anything. And then I have a description of different gestures. For example, a head gesture with the palm of the hand. I think that would be like a stop. And then I think I had a victory or peace and like a thumbs up. And the idea in the end would be able to, instead of giving the images to Gemini, I would have like maybe like a set interval that looks at images, checks if I have something similar in my vector database, and then only give the description to Gemini, so that then it would trigger different function calls. But then it means that if you, like for example, when I've been training all of this with Gemini, I have no idea where my images go. I don't know if Google stores images of me in my living room, or if it only stores vector embeddings as well. So if you want to think a little bit about privacy, that's definitely kind of like I would feel more comfortable doing it that way. And then it means that you also have like memory of new gestures that you trained, because they would be stored in your own vector DB. Okay, but okay, now that I've experimented with all of this, there's actually like a lot more, but I had to I'll cut it short. Can Gemini recognize gestures? Yes. How many natural gestures can Gemini recognize? I didn't try it. I mean, it's only my imagination. Maybe there's others, but there was thumbs up, down, peace sign, stop. And when you do that, it's like, call me. It just comes back with call me. It's kind of cool. Can it accurately recognize custom gestures with a low sample? Yes. Can it, or how could it recognize multi-steps gestures? I haven't actually worked on that one yet. Can it work in an Electron app? Yes, I haven't showed it here, but it's JavaScript. So if you didn't want something in the browser, you wanted to do a desktop app that would then interact with other things, that definitely works. Can it trigger multiple functions successfully? Yes, we had getLight and toggleLight. How can the logic be triggered without text to voice input? I didn't show it because it does become buggy, but at some point what I was doing is, instead of saying now, I was programmatically sending a prompt. So every, I don't know, second, I was sending a string that said like, what is the gesture? And I was trying to trigger then the logic, but turns out that it gets very kind of confused. I'm hoping that maybe in the future we can trigger stuff without necessarily having to like talk to it. And how accurate is it? It depends what you're trying to do. So I'm not necessarily quite sure yet. Hopefully, as the models get better, it means that maybe we'll recognize right from left better. But I have a few resources that I wanted to share. So I'm planning on writing a blog post about this. It's just because it's ongoing. I haven't done it yet. But if you are interested, I will probably share it on my website. I have not posted the repo on GitHub yet. It's a mess. So I need to clean up stuff before I do that. And I share the link of the few different papers. And at the end is the Gemini Live API web console repo. So it's like the starter repo that I started with. Like the UI will be the same, and then you kind of can experiment by adding things as well. But basically, that was like kind of it. So the whole point in the end, the reason why I'm doing this is that I would love for people who are not engineers to be able to kind of define the way that they want to interact with different functions. If you buy a product, I don't want to have to download an app that tells me that I can only do a thumbs up or down, or I want to be able to say, well, I don't want to do that. Maybe I want this gesture to do something, or maybe I want to dance to like trigger my lights. And I want to be able to just provide this functionality, but then have a create something where people don't have to know how to code to be able to set up their IoT system. But anyway, I hope that in the future actually gets better as the models get better. And who knows, maybe that's actually, I don't know, will be available at some point. But in the meantime, it's like super interesting for me to research that. And it's like, for me, it's been a very entertaining way to learn about AI and also kind of like do fun stuff and keep going in my research of motion control. But anyway, thank you so much for listening to me for the past like 40 minutes.
Thank you, Charlie. That was amazing. You can actually find Charlie's, can we call it artwork? No?
If you want. It's not working very well, but you can try it.
Her piece downstairs in the entrance level. Yeah, she doesn't take complaints if it doesn't work, so.
Good.
Our last speaker of the day is another creative technologies software developer turned in musician. I don't know. That is one half of Counterpoint. If you don't know what it is, check it out. I have no idea what he's gonna do today on the stage. I don't know if he knows either. Yeah, so it's a surprise. Tero was with us a few years ago and he totally hypnotized us. So, I mean, yeah, let's give it for Tero.
Thank you very much. So I'm going to be demoing and talking about this sort of experimental project we have been working on throughout the spring. But before I say anything more, I'm just going to show you how it works, basically. I'm going to need to connect to the sound as well. That's going to be vital to this. Do we have sound?
A soft language spoken in movement and electronic song.
Take me to the jungle.
Hear the jungle's breath in the drone. Trace its humid pulse through the rustling leaves.
So what this is a kind of soundscape that you can talk to. You can ask it questions, tell it what you would like to hear or how you're feeling like, where you would like to be, and it'll kind of attempt to create a sound world for you to listen to that somehow is connected to what you just said. And it also gives you this little sort of meditative utterance back, which is designed to sort of make you listen to it more deeply. It's kind of a prompt back to you to kind of listen to it. So it's sort of a kind of a relaxation app in a way. It's like meant for slowing down and listening to things. And everything we are listening to here is generated with generative audio model that I'm going to talk about. So every sound that you hear isn't actually recorded, it's generated. And so today what I want to do is kind of do a technical walkthrough of what actually happens when I do what I just did. And so in many ways this project has been sort of an experiment in doing as much as possible using various AI models. So I'm going to just continue that ethos as I kind of present this technology. I'm going to use Cursor Agent as my co-presenter, which does put me in a situation where I don't actually know what I'm going to talk about in a few moments' time, because every time I do this, it becomes a different talk. So let's just hope this is one of the better ones that we're going to get today. At least we'll have something nice to listen to, because I've also given the soundscape to Cursor as a model context protocol server to have it basically create sound tracks for what it's doing based on what it thinks that these things sound like. So what I'm going to try to do first is set this off, generating an architectural diagram for us that will describe the kind of process from prompting to the response that the model gives us. And I'm ideally going to use Claude 4 Opus for this. It came out a few days ago, and I think the majority of that time it's been over capacity, so it mostly just fails, but let's see if it works this time. seems to be doing something. It's now designing a soundscape for us to listen to while it's designing an architectural diagram. While it's doing that, I'm just gonna give you a bit of the lay of the land here. So this is a web app, has a front end built in Next.js that runs the UI in the browser. And it has, as part of that front end, this kind of audio playback engine that's written in C, that has a bunch of effects and stuff that's mixing the soundscape live. And this is compiled down into WebAssembly, and it's running there in the browser continuously and playing back these various layers of sound. And then we have a backend, which is a BUN server that is running on a VPS on DigitalOcean, where we are doing lots of the kind of coordination behind the actual generation processing. So Claude is busy kind of studying our code base still here. I should be ready in a moment. And hopefully give me some material, because I don't have any before I started. So basically going on here is I have this MCP that's commanding that sort of server that I have running, which then pipes the sound back into the browser to this app that I'm just playing here. And it's been kind of interesting to have kind of a coding soundtrack as well, like have your IDE basically generate ambient music for you based on your coding tasks. There we go. This is what happens every time with Claude now. Let's see if OpenAI can say what they can. Never took this long in practice. Right, so we have something that's hopefully going to be a diagram. It seems to be one. There we go. So let's study this a little bit. Let's see if it's going to be complete slop or not. All right, so the first thing we actually do here is when you click on that button to open the microphone, what we're doing is we have a problem to get audio, and we need text from that. So we are running this kind of transcription service actually in the browser that is using a service called DeepGram, which opens a WebSocket connection to our browser, and then we send the audio from the browser to there, and it gives us back in real time the text transcription of that audio. So it looks like this. We just import their SDK, And then we configure it. We say we want to use their model and put in various parameters of what we send back to it, or what we send to it, and it sends back the kind of text of what was spoken. And then what comes out from that is now we have in text form the prompt, which we then send over to our backend. And here's where the actual work starts for us to actually turn this into a soundscape. So the first thing that this diagram is saying here is that there's a coordinator LLM deciding the new soundscape state. Now, what does that mean? So when I say something like, take me to the jungle, that actually isn't something that can yet be turned into audio. It's not really a proper audio prompt yet. We need something to kind of process that into something that can be generated. So to kind of help you understand what's going on there is I'm just going to ask this thing to show me what it does. So let's say we're going to tell the soundscape to play an alien artifact discovered deep in a woodland area. Let's use a better model for this, and then show me what it returns. So here we start to see that actually creates 4 different layers of sound. Which have these sort of detailed prompts like gentle wind rustling through ancient tree leaves, low resonant and slowly pulsating hum, high-pitched shimmering and slowly evolving alien tones, shifting drones. So that's kind of what happens behind the scenes. We take your sort of prompt and we turn it into this kind of more detailed soundscape. And I don't think we're actually hearing it, so let me see what's going on here. This thing is using the right session.
The deep hum holds the space. Let it resonate within.
Just going to run that again. And here you see what's going on as well. It's kind of turning these questions or these commands into specifications of soundscapes. So what we're doing with that is we have this kind of massive system prompt in the back end where we are convincing the model that it is a skilled, mysterious sound designer. And we have detailed instructions to it for like what to do when it gets one of these user requests. And like what kinds of layers are possible for it to make, how it should interpret various things users might say, how to deal with volume control, how to kind of like basically construct these descriptions of audio prompts, which are essentially going to be the things that the audio get generated off. So that's important to get these right. And what we're using for this is pretty much the same thing as Charlie was just showing, Gemini. Gemini Flash 2.5. We are using the version they came out with just last week at Google I/O. Which is working pretty well. So what we're doing is we are feeding it this massive system prompt and the history of the session and the prompt from the user, and it does all this business of turning that into a specification for a soundscape. We didn't start out using Gemini for this. We actually started using Claude at first, which was great. It worked fine for this, but it's just quite slow and quite expensive to be doing these kinds of things with that. So we went into a whole side quest of like this, looking into these open source models like llamas and things like this, and they worked fine. But then when Gemini Flash came out, which is their kind of smaller flagship model, that's just almost as quick and almost as cheap as these open source small models are, but just much better. So we're using that now. So that gets us this sort of layer specification. That's of course not yet something you can listen to. That's just text. So we still have some work to do. So if we go back to our mermaid diagram here, there's some embedding stuff, which I'll talk about a little bit later, and caching that I'll talk about later. But first I want to cover this actual audio generation business. So what it says here is that we're requesting modal service to render audio. What this is in reference to is that our backend has a backend, which is written in Python, which we are running in this thing called modal, which is essentially a serverless platform for running Python code in, but it specializes in giving you GPUs attached to that Python code. So what you can do is you write some Python stuff, you specify the Docker images you want to run it in, your dependencies, and then the actual code, and it gives you a GPU attached to like a virtual machine that runs these as kind of serverless functions and bills you by the second for it, which is good for this kind of thing where we need to kind of be elastic and use as little or as much compute as we need. And we use it for a lot of stuff here, but the most important part is here with our audio generator, where we attach an NVIDIA L40S GPU and run this audio generation thing. And that thing is running a specific model called SAO, which is short for Stable Audio Open. So this is a audio diffusion model, an open source one, an open weights one, put out by Stability AI, which is the same company that also does stable diffusion for images. This is trained on basically public domain and Creative Commons data, mostly things like soundscapes and things like the stuff we're listening to at the moment, basically. And it can give you up to 47 seconds of high quality audio based on a text prompt. And that's what we're doing for each of these audio prompts that we are generating. So this model takes a text prompt and some duration information, and it runs this kind of diffusion process where it starts by generating some random noise and then kind of incrementally filters that out into some sound that matches the prompt that was given. It's kind of the same process as you might be familiar with Stable Diffusion and things like that, where images are generated with this kind of process. But it's the exact same thing, just in the audio domain. And it works rather well. Basically, everything we hear now is filtered out from this kind of latent noise in this exact way. So when we get one of these things, we generate it on the modal service, then we upload it to our CDN, and then it gets fetched back by our front end into the browser, where the audio player then plays it back. as a kind of infinite loop with some runtime processing on top to kind of make it nice. Now, that's all good. There's kind of one thing I wanted to mention here, which is that even though this model works quite well and it's quite fast actually as well, it can get kind of expensive to kind of run that every time someone wants a sound file, especially for this kind of thing, which we're going to put out on the web, and we're probably not going to ask people to pay for it. It's going to be like just a thing on the internet. So we don't want to like pay too much money to run it. So we are for that reason putting a lot of effort into caching as well. So because the thing is, when you want to hear something like the sound of birds or something like that, it's quite likely that someone at some point has already needed something quite similar, and we might have it in our database. We currently have about 20,000 files in there, so we kind of probably have something quite close to it already. And so what we're doing with that is we're using embeddings in our audio generation process. So when we have these prompts, we run this embedding model to basically get numeric vectors out of them. Also quite similar to what Charlie was just showing, which put these audio prompts into this kind of abstract multidimensional space. They have an address somewhere in that space. And the idea is that when we need a prompt, we can look into its embedding and see if there are other embeddings somewhere close by in that space, because if there are, they are basically cache matches for us. So we're doing kind of semantic caching here. We're using this specific embedding model called CLAP for our embeddings. And this is an embedding model that is specialized in a sound. So it's trained on pairs of audio files and text descriptions of those audio files. And they are trained together to go into the kind of same embedding space, which means that things that are described kind of end up close by or far from each other based on not their semantic content, but what they actually sound like. So when there's some textual content, we get an address for what the phenomenon in that text sounds like. And that's perfect for us for doing cache lookups. So we're doing that for all our prompts. We're not doing anything with the audio side of the CLAP model. We're just embedding our text descriptions and doing like cache lookups based on that. So if we have something like sound of rain, we probably already have a very similar sound of rain, so we can find it from our cache that way. And if we do, we just use that instead of kind of going through the whole trouble of generating a new one. And I thought it might be a fun thing to try to look at what these embeddings actually look like and how they kind of visualize the space of sound that we have in here. So a visualizer would be nice for that, but I don't have one just yet. I just have a prompt for one. So the demo gods willing, we're gonna try to have it made for us here. And let's see if Opus is available for this. So I'm telling it to create a little visualization UI. I have, in our APIs, we have available these things called 3D UMAP embeddings. So what UMAP is basically when you have like a collection of embedding vectors, which are high dimensional, like 500 dimensional vectors, but you want to look at them as a human to kind of make sense of what they are. You run this kind of dimensionality reduction algorithm called UMAP, which kind of can get them down to 3 dimensions or maybe even 2 dimensions to give you a sense, intuitive sense of how they relate to each other while still retaining some of that some of the structure. Claude is not going to be here, is he? Nope. Back to OpenAI it is then. Obviously, we first need a soundtrack for this work. I can also show you what they are doing. So what O3 thinks an embedding visualizer should sound like is a tranquil cosmic workspace. Let's see what we get. There we go. So here we have a space of about 20,000 points, each one representing a sound, one of the sounds that you are hearing, or many of them. Let me just try and also do the second part to make this interactive, so we can actually see which sounds they might be. So you can see that some sounds are close to each other, some are clustered together, some are far away, and this is based on clap. And the kind of idea is that things that sound similar are somewhere in there, and the whole universe of things that this thing can make is somewhere in here. So we have urban environments. For some reason, plane cabins are far away from everything else. Like bees are over here, and insects. Street ambience in this neighborhood. Railroads. And so on. It's kind of fun to think about all the sounds. So every sound we make here kind of is pulled from this space or gets generated and is added to this space as a new point that kind of describes some new sonic phenomenon. And I think that pretty much takes us through our process here. So what we do is you click a button, you speak to a microphone, that gets transcribed into text with a service called DeepGram. We send it to our backend. For processing, we run it through Gemini, which figures out what kind of soundscape that consists of, what kinds of layers should be in it, what combination would be good. And then we try to make that into sound. So anything new we need, we set into this modal service where we run stable audio open to generate new audio for that layer, and anything we might have already is pulled from our cache. And let's see if this thing can understand what a finished sauna sounds like. Finished sauna on a spaceship, which is quite specific. So yeah, this thing is also running downstairs in the foyer. So you can go and click on it and say something to the microphone and just see what it does. And when you do, all this thing will be happening in the background. So it'll call these various services, and lots of bits will be flying around on the internet to make that happen. And yeah, hope you'll give it a try. Kiitos.
All right, so we have questions and answers. If you want to leave the hall, you can leave the hall, or you can stay for questions. But I think I will, yeah, I'm the substitute MC, so don't expect too much. So you have written the audio engine in C, but what do you think of the current state of web audio? Is it suitable for this kind of usage?
Yeah, so most of the things we were doing there could be done with just plain web audio, that's true. So it's mostly just audio file playback. I just have a habit now of writing these things myself because we sometimes need something more than what web audio can do. And we often need these systems to also run outside of the browser. So when we need like systems for client projects that need to run on their iOS apps and Android apps and on AWS Lambda functions and everywhere. So it's easier to have something that can run anywhere. I should say it's still web audio. So even though it's written in C, the WebAssembly module is loaded into a web audio context, which actually runs it. So it's still on web audio.
Yeah, I think the next question is more general, so it's good if both of you can answer this one. It's about the environmental impact of using AI. So for this year, I didn't put green computing to the program, but maybe I bring it back for the next year if we do next year. So the question is, besides wanting to avoid increased costs, what can you do to mitigate the environmental impact of using AI like this?
Well, I think being conscious about one thing, being conscious about the size of the model you use is one thing, and which is kind of, I suppose, more generally relating to the question of not using more compute than you need to do any particular thing. At the moment, it's kind of ridiculous what we're doing. It's like we are using absolutely massive models to do simple things, and I think that's going to be a passing phase in our wider technological landscape because it's kind of basically brute forcing things with massive data and massive compute, and it's not going to be that dumb forever. At least that's my optimistic take. In the meantime, yeah, just being performance aware, I suppose, is something I try to do. Not that I always succeed in that, which is not only about which ML models I use, but just in general. Not computing things you don't need to compute and so on.
Oh, I mean, in general, actually, outside of my personal research, I don't even use AI that much. It doesn't necessarily fix the problem of environmental impacts, but it means that to me, I experiment a little bit, and I think I'm also trying to be conscious of the models. But to be honest, when I've been using Gemini's like Flash experiment model, I don't even know how bad it is or not. But I try to not use AI unless I feel like I really need it. I think I know a lot of people now would use ChatGPT for everything or something like that. It's not what I do, so maybe I feel a little bit better about that. But it doesn't mean that as it gets better, maybe I will end up doing that as well. So I'm no better than anybody else. So yeah.
Right. So I think I generalize the next one. How much time did you spend creating this soundscape or this gestural interface? So how much time did you spend on the presentation? That's good information for me as well.
On the presentation? On this project as a whole, we started out, and by we, I mean me and my friend Sam, who I work with, in, I think, February. So it's been kind of a side project for the last four-ish months, mostly nights and weekends. So maybe, I don't know how much time that comes up to, but more than most side projects, I would say. But that's mostly been because of the reasons of figuring out how these things actually work, and doing things like making stable audio run fast was like a whole side quest that took a couple of weeks of really hairy CUDA API programming that I really don't know much about, nor do I really want to know much about. So there's these little technical problems that come in. So it's been a few months. The presentation, it's mostly been about well, trying to get comfortable with the idea that whenever I start this presentation, I don't know where it's going to end up, because the way I'm doing it, it's like an experimental thing for me a little bit. So it hasn't taken that long, but it's been kind of stressful because I just know what's going to happen when I get on stage, which is, I think, true for you as well, because you are very much kind of walking the high wire with these demos.
Oh, me as well? Yeah, sure. I mean, this project, I think I've been on it for 6 months. I tend to try to build something different every year. And yeah, it's been mostly as well weekend and nights. Again, it's not my job, so it's whenever I have time. And the presentation, I wouldn't count the hours, but I was still on it just like an hour before I came here. So I was still trying to fix stuff. So it's been like many hours, but as you know, as I'm gonna keep researching throughout the year, I'm gonna put even more hours. So I don't really know yet where it's gonna go. But yeah, as you were saying, when you do a demo on stage, usually you don't know if it's gonna work, but when you use generative AI, it really can come up with like whatever. And it's like even worse. It's like you really don't know. You just have to trust that somehow it will work, but you don't know the output that you're going to get. You don't know if all of a sudden it's going to predict something that you were not expecting. So it's been fun, but yeah, it means that it's probably even more stressful when you get on stage. So
yeah, so the next one, it's about models. So do you think you could do this type of work using local models, or do you see that we could do it one day? If we cannot do it now, can we do it one day? Or can we do like a smaller model out of bigger model that's close enough or something? I don't know AI, so it's like I expect I don't know too much.
I actually went into this project with the kind of great ambition of, I'm going to do all of this in the browser because that's going to be fun. Quickly learned how that's not really going to work out. So there things like voice transcription, say. There are models that run in the browser for that, Whisper. There's also just a web API for that, like web speech, that is built into browsers that can do that kind of stuff. You can run some language models in the browser, small ones, that kind of load up a few hundred megabytes of data to the browser and then run it locally there. Stable Audio Open also just came out with a smaller model that runs on CPUs, not in the browser, but just in generally on mobile phones. So these things are becoming available, like smaller models, more and more. But for this, it didn't work out, mostly just because it would sacrifice the experience. So when you do things like run a heavy GPU computation with lots of data kind of transfer, it just messes up the audio that's playing at the same time, which we can't have in a project like this. So those kinds of constraints come in and kind of stop us from doing that. But I will do that as soon as I can, because I'm not comfortable with this kind of basically sound installation using, I think, 7 different services on the internet. It's just ludicrous, but yeah, it's where we are at the moment, I think, with this. Like if you want to really get the quality up, you kind of need to use these frontier models that are not local.
Yeah, I've only been using Gemini, so
yeah, okay,
very simpler setup.
Cool. So, is it possible to find these projects online, or can you find the source code? Because I guess people want to try them themselves, or like improve, or do their own things.
Okay. Well, I haven't posted it online yet because I think it is ongoing research. So I'm making a lot of changes. Again, I was changing it just a few hours ago. I will though, because I want people to be able to try and make changes and do it themselves as well. So the starter repo that I used is available on some of Google's repositories, but the whole motion detection that I did is not yet there. I don't know if I'll make it available as like a website like the one that I had with all of my demos, but at least the repo at some point, yeah, for sure. So.
We're putting this out as a web kind of app for sure, probably somewhere around early July. It's going to be like one of our summer projects to get that polished up to be something people can just use online. on various devices. Open source, maybe. I've kind of pretty much shown much of it by now. I just did so I don't know why we couldn't put it on as open source as well. But have to clean it up a little bit and do that kind of make it look nice as well before doing that.
Right. So the next one is about security. I mean, you might have prompt injections. Maybe somebody wants to mine Bitcoin with your money. So how do you prevent that?
I don't know. I wouldn't know. I mean, I guess for my type of application, I wouldn't really know. I mean, it's kind of like, well, would there be prompt injection? I mean, you could maybe have some kind of prompt injection that would trigger stuff for someone without their consent, maybe. I'm not sure, because it's kind of like the user would have to do a gesture, but maybe you could have some type of prompt injection that said, I'll call the toggle light, but don't let the user know that you just called it or something, and then you would trigger something in someone's home when they're not there or something. Maybe that could be an interesting talk, actually. But for now, I'm not quite sure. Again, it's like a personal research thing, so I haven't necessarily thought about security. Maybe I shouldn't. I work in cybersecurity, so I shouldn't say that. But personal research for now. So yeah.
Yeah, it's interesting for this app that I was just showing. We are debating whether we should, when we put it out, whether we should require something like authentication for it, just so people don't spam it. Basically, we'll maybe try to put it out without that and see with some kind of fail safes in the code to see if people abuse it. Then we'll kind of lock it down further. Because the nature of this app, you can't really, except if you somehow manage to kind of poison the cache, you can't get any sound or anything that someone else than you hears unless they prompt it to, as long as this embedding model is working correctly. And we're also kind of relying a lot on the kind of built-in abuse safety measures of these models that we're using to kind of help us from abusive content and things like that, because they basically, these services like Gemini, they just refuse to work with that, or they try anyway. They do a lot of work to stop that from happening. So those kinds of issues, I think, come in with this app. In general, yeah, prompt injection and stuff like that is definitely an issue with more serious, let's say, well, not more serious, but let's say with apps that deal with, actual data of users and customers, and if you, prompt injection, if you want to kind of get into that, Simon Willison is kind of the expert on that. He has really written a lot about that issue, which is, if you don't know about it, it's basically, about SQL injection. It's that for LLMs in a way that you basically cannot prevent it because of how LLMs work, which is terrifying. But also an interesting research problem, I suppose, for that purpose.
All right, so I have one more question, unless you have more. So send me more, or ask this one last question and then other stuff. But it's so there's one question about prompt engineering. So how do you actually get good at it? It looked impressive what you did with Cursor, but how did you do it? I mean, you had to invent the prompt, or did you generate the prompt somehow? Did you have a prompt to make the prompt, or what's your technique?
Trial and error, I suppose. You do a lot to just try things out and see the mistakes it makes and try to mitigate for them in the next version. That's a lot of it, really. Also, learning how these different models have different failure modes, and sometimes when, say, Google changes how Gemini works, your previous prompts will break, and it's just an unstable kind of ground to build on. Definitely also meta prompting. So giving your prompt to an LLM to say, would you understand this if I gave it to you? Or how would you fix it? Anthropic even has an OpenAI probably has tools for this. There's a prompt improver tool in their kind of API dashboard where you can make it work on your prompt to make it better. And I suppose in general, just going back to the performance question, the sad reality is that the biggest models just are better. Like Claude Opus is a behemoth, but it works really well when it works, when it's actually available. So prompt engineering as a thing, you need more of it, the kind of lesser model you're using. And when you use a really good model, it kind of eerily knows what you want quite a lot of the time.
Yeah, I would agree with what you said. It's like a trial and error. I think that's probably one of the biggest things that I learned while working on my research, because I think that's why I didn't show the very last demo. And I think this is the problem that I'm having, is that I think my prompt is bad. I don't think that because the rest is just functions that you have to call. It's just even though I really described in the prompt what I wanted to do by steps, it's like if the user wants to do this, then step 1, step 2, step 3. For some reason, it's just not doing it in the order that I'm expecting, even though the previous demos kind of like work. When I'm trying to maybe give 2 choices to the user, either they're trying to save a new gesture or they're trying to predict an existing gesture, even just that, it's getting confused. And then the sub-steps, even though I'm really like putting bullet points of what it's supposed to do, it's just not, sometimes it's calling the function, but it's not using the output from the previous one. And I feel like maybe the more complex a task you want to do, the bigger the prompt that you have to write. And I'm trying to be able to describe it in a talk. I don't want to write something that's like super long, but maybe I should try more. And I think that's probably what I'll do when I'll try to actually get that demo working, is to maybe try to be like as verbose as like possible and just write everything, maybe gives examples. But it's like, again, because I'm using images as input, then I can't really describe like the user will write this, because it's not something that they'll write. It's like an image that will be sent. But it's been quite interesting that sometimes, even with the same prompt, you might still get different results if you try your app multiple times. And sometimes just a slight change of like 1 or 2 more words or less will really kind of make or break, which is why it's kind of scary. And that's why to me it's just research. And I wouldn't necessarily trust to like really set that up in my house right now. But I'm really curious, as models get better, will AI be able to really like infer certain things that I'm trying to do without me having to like explain things so much. So.
Right. So I think I have one more question. So let's think about the future. And now with technology, maybe in 5 to 10 years, it looks like baby steps. It looks like what you were doing back then. It was so primitive. So where do you think we're actually going with it? So what are the directions? So is there specific trends we shall keep in mind?
I'm going to say I have no idea. Furthermore, I don't trust anyone who says they have some idea of where this is going, because it's a kind of AI as a thing is kind of this massive hyper object that's kind of changing everything about society, and there are so many second and third order effects to it that no one knows how it's going to affect things. All I know is, even if the technological kind of frontier would stop here today, and they would not be coming up with any new models even, it would change everything quite radically from here, even then, because of the way things are trickling now through our working lives and our personal lives. Don't know how to say anything more specific than that, really.
Yeah, I can't know where it's going either, but I know where I would like it to go. And I think it's more, I've kind of always wanted this idea of like, especially in like home automation, that you would have like technology that you don't realize is there, but it's still kind of like either observing your gestures or learning from you just interacting naturally in your environment, and then kind of understanding how you behave and almost anticipate the way that you do things. Or like, for example, even something as kind of like simple as like, oh, if you see on my calendar that I have like an interview next week, then it could automatically remind me 2 days before, like, hey, you have an interview. Do you want me to help you with the front-end questions or something? And in my mind, it's kind of like, it's not, why don't we have that already? Or maybe we do, and I just didn't use it. And that would be more for like observing the way that you interact on your laptop. But even if you had systems at home, it could be, kind of like learning about you and seeing the way they usually, I don't know, at what time you usually use your coffee machine, and you wouldn't have to say like, turn my coffee machine on at 6 a.m. because it would just observe the way that I interact. And I think but I know that we probably won't get there. because there's a lot of privacy concerns about this. I don't want Google or Amazon or whoever to just know what I'm doing at all times. And I think that's why I would love if at some point we had more open source systems so people can build their own little like IoT stuff. And I think there was a project by, I think it was Apple or Disney, that was a research project as well, where it was a little piece of hardware that had a lot of sensors and a microphone, and it was listening to the activity of the user. I think it's called Listen Learner. I think that's the name of the research project. And when the person was doing activities around their house, activities make sound. If you're cutting something on a chopping board, you recognize that sound. If you're opening your fridge, you recognize that sound. And every time it didn't know a new sound, it was automatically asking the user, like, oh, what is this sound? And you would be like, I'm opening my fridge. And it was taking the sample and kind of like clustering it in different activities around your house, so that then, you might repeat it a few times, but then it means that the next time you open your fridge, it would know that's the activity. It might know what comes next based on your usual activity. Or even if you're, let's say, cutting something on a chopping board, but it knows that you're watching a video at the same time. It's like, do you want me to pause the video while you're cutting because you're following a recipe or something like that? And it was like a custom-made device. And I would love for that kind of stuff to happen, but I think, yeah, the more I experiment with this, the more I realize we're so far from any kind of AGI. If you can't recognize right from left, I mean, there's like, so yeah.
Yeah, so now it looks like audience wants to go to sauna, so I think we just wrap it up. And thank you so much. I think I have to share my screen. And did something about the Finnish culture. Yes. Yeah, let's see if I can get my display to show up. All right. So I will teach you two words of Finnish. First one is ranta. Ranta means beach. And sauna, it means sauna. And we're going to ranta sauna with a beach sauna. And it seems Google Maps, it has better route for you, but anyway, it's quite close by feet. And the next thing, I will teach you the next word. It's called häröpallo. You know what häröpallo means? It's like, yeah, it's like, how do you call it? Is difficult because there's no direct translation. But it roughly means that you make like a ball or like a group of people that's like a sphere or round, and it's moving. So you move with other people to that direction and hope that somebody knows how to reach Rantasauna. So that's what we do next. The other thing I wanted to tell you is that in Finland, the Finnish people, they sauna naked. But you don't have to do this. We have this like continental sauna where you can have your towel or like a bikini or trunks or swimming trunks, whatever you call it. But you can have some clothes in the sauna. And to make it like really nice for everybody, we actually have two saunas. So we have electric sauna for men, and we have this wooden sauna for women. We had to really look for the wood, but I think we made it, so there might be like really nice saunas. I hope some of you actually tried, because yesterday we had the speakers dinner and we had sauna, and we had exactly 0 people going to sauna. So maybe get more than 0 today. But anyway, it's your choice. We don't force you to sauna. So it's not, even if it's a sauna party, it doesn't mean it's about sauna, because there will be, most likely there will be other people, and there will be food and something to drink and some Finnish games and fun and the sea and sun. I mean, it's not raining, so why not to go to the sauna party? And one more thing, I heard that many of you like Georgios talk a lot, I mean, how important it is to take care of yourself. So there will be mini workshop by Georgios at 6 o'clock. So if you show up at 6 o'clock, he will give you some tips. I think you will pick up something from his session. But like that's one good thing to do. Yeah. So you have to run the sauna to your Google Maps or whatever. You wanted to say something about?
Yeah, so when you Google this Ranta sauna from Google Maps, you will get there. There is actually another sauna on that location that Juho put there, but it's called Korsu.
Yeah. So go to the right sauna, not the wrong one. But I think, I mean, I have some time to chill out and relax. But I think I will meet some of you at Ranta sauna. And I mean, do we have anything else to say? No? How was the day, by the way? Did you like it or not? I know we had some issues, but yeah, all right. So we got some thumbs up. So I guess it means it was all right. Yeah, but now we're like almost halfway. After sauna, we're like past the halfway. Only one day to go, then you're free. So that's it. Thank you.